turn it over to the Common Repository Working Group for discussion, and then after that we'll have lunch, and the posters are downstairs, so during the lunch break.
So just to restate what Tom pointed out yesterday during our session, I think our goal is by the end of the meeting on Thursday to have a set of recommendations that hopefully the community would agree to adopt. So I guess that would be the focus of this next hour, is to specifically discuss the recommendations that we put forward yesterday as a draft for review. Hopefully people have had an opportunity to read through that. We did get one set of suggestions on our website. Thank you very much. I don't know whether the fact that we didn't get more means everybody loves them and is ready to sign off, or whether it's just because you've been so busy with the meeting. But in any case, please bring up your suggested revisions now, and also, put those in on the website.
So as I was your contributor on the website, maybe and thank you for your replies. And my first issue was around what happens if the databases that you're linking together don't have all the metadata that you and the other working group have requested. And your answer, I'm sorry I spent my time writing the suggestion based on yesterday rather than reading the report, but your answer, which I didn't understand in the discussion yesterday, is that any of these databases that you link will be obliged to capture all the metadata that you're capturing. And so, that sounds absolutely fine to me from that point of view. The other thing that I suggested was it wasn't so much a clear proposal, but it was trying to get a little bit of discussion around licensing and obligations and things like that. And I mean, there was some discussion yesterday about do we need do we need a license? Is a license a good thing to have on the site, or should there just be simply expressed principles? And my feeling was simply expressed principles might be better, or even if you do have a license behind, the thing that's important, I think, is to bring out in principles alongside that license what you're actually asking people to do, because I don't think people are very good at understanding what's in licenses. And the two principles that I thought were really important, one was that you won't allow people to put restrictions on stuff that they do with the data. And the reason I think that's important is because of where we've ended up with the germline libraries. And the second was, you're saying, as I understand it in your recommendations, that it's a good idea that people should acknowledge their sources, and but hey, it's just an idea. I think we should say people should acknowledge the sources. And you said, well, in your reply to me, you said, well, you can't force people to do things. Well, that's arguable, but I think the principle should be that we expect people to acknowledge the responses that are acknowledge the sources of data. And there are ways that we can exert pressure as a community on people to do that. We can name and shame. We can, if we happen to be reviewing things, we can say we don't think you've specified where you got your data from enough. There are things we can do, and I think we ought to.
Yeah, No, agreed. And just one of the recommendations that we didn't talk about yesterday, because we have 22 altogether, and just due to time yesterday we didn't discuss all of them, but one of them is that we recommend that the repositories encourage and facilitate appropriate attribution. So obviously, okay, it's on, I don't know what, I'll slide it forward. So obviously we can specify more details about how we would go about encouraging and facilitating, but we agree with you absolutely that that would be an important thing for the repositories to do.
So for the IDB, our citation guideline has been, if you're using data from the IDB, please cite both the database and the original publication from which the data is derived. The problem is, if you say doing something like, I'm going to query for all influenza epitopes and then look for what is the dominant region, you're going to have to cite over 1,000 papers. And no journal is going to let you do that. So this is where, and then there's this whole, who said it, like acknowledgement stacking. This is the problem. Then maybe you're citing a paper that gets the data from somewhere else, and where do you stop? So it's, unfortunately, it's not a perfect world. So we cannot demand people to cite 1,000 papers because they simply won't be able to. Yeah, if you essentially go to this site and you would actually, you would ideally say you should say you have an epitope that's in 10 papers, you would cite the epitope ID, and if you go there, you have the 10 papers listed on the site, so you can reproduce it. But it's obviously ideally people would want to see their name in the paper that uses it. But yeah.
Sorry, I'm trying not to slow things down, but I think in those circumstances we should say what we expect people to do. And by the way, I quoted what the flu site does, and it's a big issue for that as well, because they have another thing, which I listed in case we wanted to consider it, which is they put an obligation on people to make efforts to involve the original discoverers of data in their research. And again, if you're doing a search that involves 1,000 different data sources, then it's very difficult to do that. But I think we should say what we expect in those circumstances.
Question. I guess I wasn't here yesterday, so perhaps this was discussed already. So how much existing infrastructure are you guys going to sort of tap into to create this repository?
Yeah, we recommend tapping into existing infrastructure as much as possible. And so utilizing, for example, SRA for deposition of raw data. And then there are several repertoire-specific databases that already are in existence, and then including, for example, the repertoire sequencing data that Bjorn mentioned in IEDB. So we think that the best approach is to create standardizations that allow interoperability between these existing infrastructures rather than going out and creating a whole separate new infrastructure. Okay, let Uri say it. Bjorn said it already, actually.
Yes, use existing infrastructure.
Precisely.
SRA, and then taking advantage of some of the repertoire repositories that already exist, basically. And I guess one thing that this will be real when all the people that run those repositories right now realize that they're going to have to rewrite a good chunk of their code.
I guess the other question is, so is the goal from the beginning to really enable like productive reuse of this data versus simply being a repository? Because to do the latter well, I mean, there's a lot. We discussed some of them already in our talks, but so yeah, so that's just a comment.
Yeah, I mean, I think also the trend in data analysis in general is that people are moving compute to the data. So I think kind of one of the things that the tools that we're proposing would support would be to enable you to run queries on people's repositories rather than, and this is especially more relevant to kind of downstream data of already annotated antibodies and T-cell receptors, but rather than doing the kind of typical thing of first step is download all the raw data files and then like curate them for my own pipeline, it would be great to support tools so that you actually just run your queries at people's repositories.
Were you going to follow up?
A very quick one. So I guess the key question is about the annotations and the functional information, right? So a lot of these are raw sequencing data. So there's more and more, like, for example, single-cell cloning of these antibodies and functional information about them both in vitro and also in vivo. So are those, is the goal also to capture those types of information in a structured way here, or it's simply as a repository of the raw sequencing information and everything else would be separate?
I think we would love to capture that information. I think that's number 8 or 9 on the minimal standards list, but that would be great to incorporate that as well.
So I was thinking one of the, maybe one of the gaps right now is dealing with queries. I didn't see a lot of specification in the type of queries or the query semantics that are going to be allowed. So I know there's some discussion there in the infrastructure of like how you're going to get the repositories to provide maybe some common interface or so on. Is the idea that it's going to be sort of a fixed query semantic that is a certain way that you can do queries, or are repositories going to be able to sort of innovate in that space? If that makes sense.
I think the way we're envisioning it is that it would be both. So there would probably be a minimal set of, so if you incorporate the data types that are kind of mandated here, then you should also support some minimal set of queries that you can run on this, on that data type. And then after that, it's basically up to any repository that they could choose to implement whatever else they want.
We'd like your feedback on what.
Add that we put as future work for the coming year to specify the queries, and so we would invite everyone to contribute to saying what would be useful queries to the community, so we can then prioritize what should be supported by the repository.
See, Steve has repositioned himself closer to the microphone.
So one of the recommendations was to use Thrift and Avro maybe. Can you say a little bit more about these, I don't even know what to call them, file formats, queries?
So they're serialization frameworks. They're commonly used in when you're storing large amounts of data. They kind of came out of the technology that was developed to process data at like Google and Facebook and Twitter and that kind of thing. Basically, you get to specify a schema for some objects that you want to process on, and essentially you get a set of tools at that point where you can generate clients in 20 different programming languages. So once you specify kind of what the data objects you want are, so you can specify a study, you can specify a immune receptor, etc. You can, from that specification, generate Python code, C code, Java code, OCaml code, Perl code, whatever, where all of these things will be guaranteed to be interoperable. In addition, they're kind of compatible with JSON. They are basically, you can kind of think of it as like a very efficient binary version of JSON for storing and communicating data. And they're also they also code gen for you. So in addition, the other thing you get for free is implementations of essentially like web servers. So you can automatically generate the kind of front end for like the IDB website. And the implementer can choose to implement the website in Java, for example, and then someone else who likes writing their scripts in Python can access that website, and everything kind of works seamlessly, works efficiently. And in addition to that, there also, by using these tools like Thrift or Avro, you get access to file formats that have different properties that are also potentially very efficient. So if you have if you have a big pile of antibody receptors that conform to some like Thrift schema, that means you can then store them as a JSON file on disk, or you can store it as a Parquet file on disk. And all of the code that you have is automatically interoperable between the different types of file formats. And so if you prefer JSON because it's easier for you, or you want to kind of debug things, you can do that. If you want to have like very high compression and kind of more optimized query performance, you can store it in Parquet. The main thing is that the main idea is that any different parts of a computer system that want to talk to each other about these data types have just agreed to a contract that they're going to use the same exact binary format. And then it opens you up to using a large number of tools that are kind of in the open source and that already exist, designed for kind of doing large-scale data management.
So how do we address the educational bit about that? Because there's a lot of stuff out there, but I mean, you can go with API definitions in 5 different formats that will generate clients in 20 different languages too. Right, so introducing people to different ways to store their data, different ways to query it. There's a discovery problem in there that still needs addressed. And there's largely an educational bit that you need to go out and engage with the community to teach them about how to do this stuff, because they don't have funding, right, to sit there and learn about new technologies. They don't have developer time to go back and re-implement things they already have. So how do we kind of bootstrap an existing population of scientists with these new technologies, knowing that they're 18 months away from the next one?
That's a great point. I think there's kind of 2 populations of people here. So one population is the people that are actually building and maintaining these repositories, and they're kind of screwed no matter what, because if we all agree to a single common representation, they're going to have to change something about their databases. The other group of people are the actual users of the database. And then I would argue that interfacing with a database that exposes such a Rift API, for example, is actually not any more complicated than using any like REST API for a website or anything like that. I think the best thing to do, and this would be part of future work, of course, would be to actually have a reference implementation and show examples of how, basically tutorials. This is how you would connect to this database. And I think it would be every bit as easy or difficult as it already is for pretty much any other database. In fact, the one way in which it will be easier is that if you figure out how to connect to one repository, then if you use these tools, you are basically guaranteed to be able to connect to every other repository.
Just want to talk a little bit and just get some clarification, because it seems to me we may be talking about 2 different kinds of repositories, and I just want to make sure we're all on the same page here. There seems to me that there's one kind of repository where the raw and maybe some minimally processed data is going to sit. This would be like the equivalent of Geo in the presentation that John made this morning, right? So that's like potentially SRA, where all the raw sequencing data goes. Maybe there's some minimal processing to make it a little bit usable. And from minimal standards, we would propose that is kind of up to the point of VDJ assignment. But then there's sort of a second, sort of a derived repository, which has some maybe additional processing, maybe improves the metadata, where you can do more advanced kinds of queries, like was mentioned before, about finding common CDR3s across multiple different studies. And that seems to me to be a different thing. This would be the kind, again, sort of the kind of meta-analysis engines that John was presenting this morning. And there seem to be two different issues and different questions we have to address. Is that right?
Yes. I mean, the only thing I'll add is those can be implemented together. For example, I think that the proposal as it is now is to use SRA because it exists and it is durable. And then SRA gives you some small amount of metadata that you can put in there. I think that you would separately have the kind of, if you're talking about like an actual MySQL implementation, then you have SRA's MySQL, which has their small amount of metadata on there, plus a pointer to a huge amount of storage. And then we would have our own MySQL, like VDJ server or iReceptor would be its own MySQL instance that would contain all of the additional metadata, and then potentially also include the receptors themselves, which I think is probably similar to the way things are today.
I think we need to get that piece about where the metadata is in the recommendations somewhere. We talked yesterday about could we get all the minimum standards metadata into SRA. I just think we need to be specific about where it is and how you query it.
So just as a point of fact, biological metadata for SRA is stored in the NCBI biosample database, and that is expandable ad infinitum. So if you can get your submitters, i.e. the people in this room, to submit regularized metadata, we can store basically as much as you want. In addition, in terms of, I'm really a huge supporter of linking to other people's databases, particularly, personally I am, particularly IEDB, I think that's very exciting. And the thing is, on a project level, we already have an unambiguous mechanism to look out and preserve accessions from the original databases. And so that's actually a fairly straightforward thing to do right now. And so we could link out to IEDB fairly easily. There's probably still some things to work out in terms of sort of beaconizing things on an individual sort of run level with the SRA, but those are discussions we'll probably continue to have. Oh, sorry, yeah, my name is Ben Busby. I'm the Genomics Outreach Coordinator for NCBI.
This is a perfect comment because there's other communities that use that same kind of model and with GenBank where they flag their records in GenBank as having met a certain metadata standards and quality control. And then there's specialized community databases which have more tools, analytical tools. But base data is still stored in GenBank with metadata tags. So you can use both the specialized tools and store data in GenBank. So it's a really good model. It just takes coordination and discussions with the power.
So yeah, I mean, in my personal opinion, that's kind of where we all want to go. Since I'm up here, somebody made a point earlier about moving sort of the computational tools to the data. Also, so we have a Internet 2 connection to Amazon and other major cloud providers. So if you wanted to do sort of a cloud thing, I mean, unless you're trying to move terabytes and terabytes of data off of dpGaP or other parts of SRA, if you're moving fairly selective parts of data, it's essentially real time to come from SRA, and we have this vertically oriented database model to be able to do that. And we have educational resources on doing that kind of thing if people are interested. So I think that's.
Yeah, we had talked about, and also, I mean, specifically talking to you and enabling ideally a user submission process that they don't have to go to 3 different places to submit their data, but ideally there would be one portal where they submit, and then that would be tied to an SRA submission, and maybe there would be a pre-validation that the metadata is in the shape that we want it to, and then that goes into SRA, and obviously would be perfect to coordinate this because we don't want to have the users have to go through multiple steps to make one submission.
So that's actually, we have, what I can say is, because I can't really make big promises based on NCBI, but what I can say is that we have several similar collaborations that we're talking to folks where they can take sort of domain-specific metadata and integrate it and then submit it to us. So we have large submitters like Broad, for example, where they submit through an automated computational pipeline. So if a particular community had a repository where their submitters could put in whatever kind of form you want, and then you could just make the metadata into pre-configured XML and do the data dumps yourself. Actually, the data dumps could come straight through them, and then you could submit the metadata. That's something, like I said, that we're working on with other communities, and we have worked on with other communities.
So then is the do you offer does SRA enable the ability to query on like the structured metadata? Like if I submit like a custom set of metadata that's application specific, the data becomes structured in SRA's databases, and then there exists like facility to actually query like particular fields.
So we have a concept known as the run selector, which is sort of a Solr indexed metadata table. And so, yeah, you can search on those fields.
But it's like text searching is the idea. It's all like text matching.
Yeah, so it's faceted based on Solr tagging. Yeah. I think that should answer your question.
We also don't have to talk for an hour.
I mean, I think to think about is the more we discuss today, the easier Thursday will be, I think. I mean, we'd like to leave here, right, with some initiatives so that we don't have to do this again.
So the only other thing I'd mention is again, specifying schemas through something like Thrift or Avro makes it easy to also have data dumps in kind of compatible formats so that you don't, one of the things that it would do is it would relieve us as a community of having to specify and maintain a specific file format, but it would still enable us to use kind of tools that can read standard file formats. So we could, for example, take all of iReceptor or VDJ server and just plop it in a compatible format in some like S3 bucket, and then have people kind of do raw data, or run kind of batch processing there.
So I had a pretty general question, I guess. When you presented your recommendations yesterday, and we were talking about like a registry, and then we were talking about running queries, and then I was thinking, oh, well, so this is going to take like some real resources to maintain this. But now listening today, I mean, obviously there's resources, and obviously the repositories are going to have to be supported. But listening in today, so then I realized, so if we really put all these standards, it's possible that you won't really need a lot of resources at the center to maintain. I mean, it always takes something, but it's not a, you guys obviously thought about it.
Yes, and that's the design. That was the goal. To essentially have a I mean, the center could be very minimal in terms of just a registry. This is the list of officially accepted repositories. That's it. Because obviously the center is where the power is or whatever, and then that would be it can be, if it's that's very lightweight, it can be totally managed by a community like this and having consensus decisions, and because it's very little then controversial. Hopefully that's there.
Lindsay just mentioned that not all of the recommendations that you have, I think you said there are 22 of them, not all of them were presented yesterday. Since we are going to be trying to come to consensus and ratify these documents as a group, maybe we should have a look at them. Just, is it possible for you to put them up? I know that we're all going to be downloading them and looking at them, but I think that rather than leaving that to chance, why don't we put them up and see if there's anything that anyone wants to talk about while we have the chance.
Absolutely. And the GitHub link that we mentioned yesterday, in addition to having the issue tracker where people can request revisions, it has the actual document there, so everyone can read, but we can project it. Yeah, I think you put it on the AIRR site.
Also linked in the document.
what was it? Is
So the way we designed the recommendations, so as mentioned yesterday, they fall into 4 different categories. So one is on sharing and access, the other is on infrastructure, the other is on the nature of the data to be shared, and the 4th one is on coordinating with the NIH Commons effort. Within each of those, we have recommendations that are would be considered required for any repository that wants to consider itself to be basically blessed by the community as being in compliance with the recommendations. So for that, status, if that means anything, that would be adherence to a subset of the overall 22 recommendations. And those were the ones that we focused on in yesterday's discussion. And in this document, if you scroll up above where it says detailed recommendations, there it lists specifically the ones that are required for compliance.
I would be a little worried about time, and but I mean, we could. But then I just also want to point out that there's a reason why we didn't make them required, because there was some level of controversy. So I would expect them to be controversial. That's why specifically we didn't make them required, but just that we have talked about it. This is our current thinking. So I would be not surprised it would take quite a long time to go through the whole thing.
Yeah, the point is we have another 16 or 17 minutes. And we are trying to, as I say, come to consensus. So this is the opportunity for people to bring up any concerns that they have. It would be much better to do that now than to wait until Thursday when the time is even shorter.
Absolutely. Just to clarify once more, we would not make the non-required ones something that we want to have consensus on. I think our goal was to have a consensus on what we consider the required recommendations.
I scroll down?
Everyone raise your hand when you're done reading. When every hand is up, we'll scroll.
Well, is it actually clear? Can you show us in the wording how you differentiate between the required recommendations and the recommended recommendations?
Mostly we tried to say we recommend blah, 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 or we recommend requiring blah, blah, blah.
Well, what about strongly recommend?
In addition to that wording of specifying we recommend requiring X, Y, or Z, we also, in this top part of the document, where it says note, I guess we should have made that like more prominent than just note, but that section that he's highlighted specifically lists the ones that would be required for any repository to consider itself in compliance.
I think we should make the wording clearer.
Okay.
I think we should, under recommendations, I think we should say these recommendations are divided into 2 sections. There's a section which we require any community repository to follow, and then there is separate good practice which we encourage those repositories to follow.
Absolutely, and we should renumber them and everything. I think this is a historic thing. We had them by topic area, and then after multiple iterations, we found the ones that we actually have consensus on in our group, and those we made recommended to be compliant, and the others are still there. We should totally rewrite the whole thing, yes.
The other thing I would recommend is adding a section on governance. Because right now you've got a lot of whats, but you don't have anything about who. And I think that will shake out once you've worked out what the whats are. But at some point, someone's going to have to take responsibility for some of these issues. And when you're looking at that kind of consortium structure in the middle, where you've got federated databases, You can either leave it to agreements as between databases, which I don't suggest you do because that becomes really messy really quickly. That is your attraction point in terms of being able to have some level of building of community norms. That's your strongest touch point in terms of I don't want to go and use the word enforcement because I think that's too strong a word, but at least in terms of structuring or building what the expectations are, or with exceptions as appropriate, as we discussed yesterday. But at some point you're going to need to have, is your registry actually going to take some form of charge? Is it going to be a legal entity of some kind that would then mediate the relationships with the repository? Or is it going to be much more kind of a looser recognition from a society or something? But you will have to pay some mind to the governance of the system.
And then I just want to point out that this applies obviously to all the recommendations. The same should be for the data standards and the other ones. So, you asked, and I don't know, is there a society, an AIRR society or some kind of entity? I think that would be very much useful to. Okay.
You should also get the URL and register it somewhere.
And while we didn't, I think Tanya's suggestion is a great one, and we obviously didn't go far enough, so we will take that farther. But we did in several places specify that this community and its working groups be the forum for making decisions about things like, what's required and what's not, and what has to be adhered to, and what the standards are, and so forth and so on.
Just point of information, tomorrow afternoon we have the future of AIRR discussion and working group, and that one big thing will be, do we form a society? Are we a consortium?
I would like to make a recommendation to this particular group to include something in there around carrots. What incentivizes people to participate, to buy into varying degrees, and also to make a nod to the resource providers and get them involved in the board, the planning, the governance of this, because they're the ones that are largely going to have to bear the cost of. No matter how minimal it is, they're the ones that are going to have to bear the cost of it. So making sure you have their input, I think, will go a long way to getting some practical adoption.
So that, yeah.
I'm Ryan from Text Advanced Computing Center.
That's an issue in a lot of communities, and it's about choosing the right metrics that you can feed back to the community so that they can be incentivized to behave in specific ways. And most people are, academics of some ilk or another, and so that attribution piece is the most important. So what's worked in some of the repositories that I've worked with is some like citation or utilization metrics, so that you get, from the repository you get a tag to say your data has been downloaded X number of times, so that you can use it as an attribution citation statistic in your annual reports or institutional credit, whatever. Things like that. Yeah, so if you've got an accession number, I'll use mouse line as an example, or mouse data. You would get your line has been requested so many times, your data packet has been requested so many times, and you would get those citation statistics from the repository. It's a fairly easy thing to do.
Tanya's point on governance, I think, is really important, and one that I think, went beyond the way that we were thinking about this when we came in. I wonder at what we should do at this moment, because we don't have a society that we can sort of point to and include in these documents. But I think that saying something about governance and how this is going to be moving forward is important. So I hate to put you on the spot, but I wonder if you can recommend how we might sort of finesse that for now.
I think moving forward with the society, if that's the will of the community, is going to be an important step. Otherwise, you're going to need to sanction, some form of secretariat, whether it's, centralized or roving. But there needs to be somebody taking the lead and in charge of an endeavor like this. But there's a balance between having that what appears to be a very top-down approach and being that sort of, right now you're still at the momentum building, grassroots, we need this. And so I think these are the really important first steps. But I think one of the things that you probably want to come out with on Thursday is some kind of understanding from the community as to whether there is a willingness to create a society or some kind of formalized structure around this community. Does that help?
I believe really strongly in your recommendation to have users submit their raw data to SRA. However, industry doesn't always give out their raw files. And what are we going to do when the users don't have access to the raw files that we're mandating or requiring that they be released to this public database?
We talked about that a lot. We acknowledge the problem. We don't have any solution.
Have we
so
talked to the companies as a community to try and convince them that this is really important, needs to be done? And maybe I think their concern is perhaps that there are, Adaptive, for example, has a synthetic repertoire that they include in their library preparation, and releasing the raw files would give out that information. Maybe they could somehow extract that proprietary information from those raw files and just release the user sequences. I think we have to have this discussion with industry now so that we can persuade them to make this available.
Yeah, we have reached out to specifically Adaptive. Here, let Yuri say it. We have reached out specifically to Adaptive and other companies. We don't right now have much leverage. I think ideally when journals and funders start requiring submission, that is really where the leverage is going to come in to put pressure on companies to come up with creative ways to release raw data but still protect their proprietary interests, like removing the synthetic repertoire, for example.
So hopefully this will be useful enough that they want to participate just on the merits.
I was going to say the same thing. The way the language here is around IP is fine. If something's in GenBank, it's open. I mean, we understand that. And I've been sort of thinking about this overnight, but it's requiring people to put things in that you're not mandating, but the same people who are going to do that are in the room, editors and funders. So that's going to be a separate discussion when a statement, because I'm giving you money or publishing, I'm requiring you to deposit into this third-party database. That's, I guess, a separate discussion, but it's going to be us too. So that it seems like to me there needs to be an accommodation for people with intellectual property to curate what they are required to deposit. It's a balance between full disclosure and, like you say, Adaptive has information. You can't, unless they're completely dependent on federal money or publications, you're not going to have any leverage there anyway. But others are going to be tied into those publication and funding systems, and compelling them always to reveal their intellectual property is not, it's just not sustainable. So there needs to be some kind of, not for this end, but the requirement in some kind of modulation or.
So I think there's multiple valid reasons why somebody will not be able to comply with submitting all the raw data and everything, and that might be IP, that might be because they don't have access to it, and I think we should acknowledge that there's a reality of these things, and it's not that we'll not take data. So if there's somebody who only has assembled processed receptor data, and say it's only CDR3 regions or so, we would that data is still very valid and it can be useful and it should be captured. So I think the recommendations we are doing in this regard are, in the ideal situation, this is what should happen. This is the perfect submission. But I think none of us would say the repositories will just simply will not take data that doesn't live up to the perfect standard that we are striving for.
And actually, the what you did in the IDB, where people don't agree what an epitope is, saying these, in my opinion, I click these buttons, these are low quality, I don't want to see them. You could manage it the same way, like scoring sets as lower quality because they're not, the backup information's not there.
I mean, if you look at all of the rules, even from the funding agencies that have been promulgated on a variety of different open access or open data kind of frameworks, what they do is they set out a default rule, and that should be followed as much as possible whenever possible. But there's always exceptions for proprietary data.
So I'm just a little confused about what Jim brought up, or maybe speak to it, Jim, too. So the natural sequences are, I guess they're intellectual property, but it seems to me like those are not something that you can by themselves patent, and that it's what you figure out, that you invent through your knowledge that you've gained through that is the intellectual property. And that, I would assume, that with these databases, anybody's free to do.
Yes,
so where is the line there? Because this was discussed yesterday, and it really needs, maybe it's not a clear line.
Yeah, so I think there's some confusion between what you can get formal intellectual property over and what is still considered proprietary information, right? So what you can get formal intellectual property over, so say, for example, something is patentable. If you get a patent, the reason that a patent is the strongest form of intellectual property for a limited time period is it gives you the right to prevent others from. Okay, so that means prevent others from using, manufacturing, making, and the various sort of statutory things, right? With using being the most predominant thing. In the U.S., at least, you've had your research exemption has almost been wiped out unless you're doing things for clinical development. The trade secrecy protection, which would form over the data in a proprietary database, is much weaker because it prevents, it gives you the right to control access to it, usually through contractual means, right, through a data transfer agreement. It gives you, therefore, it doesn't give you patent enforcement rights, it gives you a remedy in contract for breach of contract. But once that data is out there, you only have breach of contract with the party with whom you have the contract. If they accidentally release it and then it gets picked up by third, fourth, fifth parties, you have no legal rights against them except in some U.S. states where there are some trade secrecy protections. So it also doesn't give you any right to stop another entity from independently creating that data, which a patent would. So that's why it's a much softer, your remedies and your protections fall in the fact that it's mine, that I control it, that I have it behind a firewall, and it's all governed through these sort of these contractual rights, and your remedies are in contract, right? So that's. But with a patent, you can prevent others from independently creating it, right? Because you can prevent others from using. And that's the core difference in the muddle that we were getting into a little bit yesterday, is this distinction between formal and statutory intellectual property rights like patents or copyright, which actually doesn't prevent independent creation, it just protects you from copying, right?
But my thought was that these are natural sequence databases, and therefore they're unpatentable, I thought.
Well, sequences were patentable up until a while ago, and now the law in the U.S. is all up in the air. And Europe, it's a little bit different because you need to have you still need to meet the utility standards, and they're a bit higher in Europe than here. I would say right now it's very, very, very questionable whether you would have any formal patent rights. But that doesn't mean to say that you don't have proprietary interests in the data itself. It's just that it's protected through a firewall and through contractual relationships. I hope that makes sense.
Yeah, and can I just clarify? Not all the sequences, I think, for a lot of people doing sequencing now, are natural. They're adding sequences, barcodes, and things like that, before any sequencing occurs. So when the very first reads are generated, they can have natural and
Mm-hmm. Yeah, and it's only the naturally occurring sequences that the myriad cases really kind of wiped out, right? So if you have synthetic sequences and you're adding things, certainly if you've got a vector, you know, for CAR T cell therapies, for example, that's very valuable, very patentable intellectual property.
It's probably up to a jury to decide whether cutting out like the synthetic sequences from a synthetic construct that includes an antibody would kind of make it natural, or would this continue to stay synthetic?
That would not fly. I would think that we consider it natural, definitely. But maybe just clarify, because also I talked to Jim, and I think I really understood better. I think the case he's outlining is because at the moment if you're an investigator and you have a repertoire sequencing data that might contain some antibodies of interest, so if you're depositing them all in the complete raw format with every information that you get there, essentially anybody can take it and do whatever they want with it. And so to protect yourself before the typical thing is a company would, before you disclose these things, you might be able to get a contract with a company that say, okay, I'm going to take these sequences and engineer an antibody construct for production, which is no longer it's going to be based on the natural sequence, but then be artificial. This is the typical thing that these things go right now. And so the moment if you're mandated by the funder to disclose these things immediately, you would lose that time frame that you have. So this is a real NIH policy issue. Like what is the mandate in terms of, do you have to immediately submit every bit of repertoire sequencing you do to these databases? So, and I think from our perspective, that's an NIH policy or funder policy issue. That is not a repository. How do we deal with it? In our mind, at the moment, it ends up at the repository. We are not going to try to impose some kind of control who can see it, because that would be a technical complete nightmare, and we would never want to be responsible for accidentally disclosing something that is worth a lot for someone else.
And also remember that you're going to disclose those sequences. If you are filing patents, you're going to be disclosing those those sequences in your patent filing. And in 18 months, they will be published. So I mean, it's the same that you have a delay. So regardless, they're going to be in the public domain. I mean, that's the bargain with a patent, right? So if you don't want them ever being in the public domain, then you keep them behind a firewall, but you don't patent either. So the quid pro quo for the patent is that you're disclosing all those sequences in the patent document.
So just to sort of follow up the point I brought up before about sort of these two levels of repositories that we seem to be talking about. If I read the document now, it seems to require two things. It seems to require, one, that the data be deposited in something like SRA, kind of the base data. And then it also seems to require that the data, in addition, be deposited in what we're calling a compliant repository. And that's the thing I'm not sure about, because the way we're talking about it, it seems to go, we seem to be going back and forth about what the requirement is actually. So in the minimal standards working group, we were suggesting that we require deposition of the sort of the base data into something like SRA, but that the deposition into these derived repositories be recommended but not mandatory, that we don't tell journals that they have to require deposition in these two places. And I think that's something we may want to come to some agreement about what we're going to suggest journals do for these data.
My opinion personally, and I think we've clarified that, I didn't make that distinction in my head. I thought this is one, yes, there should be a journal recommendation for requiring an accession number at one of these common repositories, which would then be linked to the SRA submission. So I thought this is one thing that should be, I mean, that we would recommend journals to require. Similarly, like they would require submission to the PDB or epitope data to the IDB or whatever. Which is obviously up to the journals to impose that.
And but what's open is what that second data type is, I think.
Well, I guess.
And I think the other thing is the raw data does not necessarily need to be in the second repository, right? Only metadata and then potentially later on annotated receptor data.
I mean, this is why we need to work with minimal standards, because that's where that big gap is.
Yeah, I guess I would make an alternate recommendation that at this point that we ask journals and we make a requirement that people deposit metadata and data up to the point of VDJ assignment, and that's at this point that's where our requirement ought to end.
Right, but then I guess the question is still, does SRA take those data? So, I mean, maybe that's something that Ben can comment on. I don't know. I think at the moment that's not standardly done, but...
The other thing is, once you enforce this one requirement on people to put it in the SRA, if 2 years from now we want to change it and then also require them to submit something to one of, like an AIRR repository, I feel like that would be much harder to require more stuff. Like, in some sense, I feel like make all the requirements you want up front. So get them to deposit. This may be my personal opinion, but get them to deposit in an AIRR repository, get an accession there, which requires them to also have an accession from SRA. But that's up for debate.
So just speaking to the sort of SRA GenBank type stuff, so actually, in my personal opinion, what you just said makes a lot of sense. But going back to the previous point, so SRA itself does not take, say, assembled sequences and so on and so forth, but GenBank certainly does, and it's very easy to link between GenBank and SRA, as co-panelist alluded to. So you could do that, and then you could also link between those and something like IADB. And you could do that unambiguously while preserving the accessions, and then have the whole sort of milieu up in air. And I don't think that that's necessarily, in my personal opinion, that need not be all that particularly difficult, as long as you say, everything is laid out clearly at the beginning.
A lot of the discussion that we're having now about intellectual property more properly belongs, I think, in the minimal standards discussion. So I think I'd like to emphasize Corey's suggestion that the minimal standards and repository groups really work together and decide which recommendations go where and make sure that they're harmonized between them.
So I think Steve made a really nice picture he's going to show us later. Is that right? Yeah.
Mention that, so again, the people that ordered boxed lunches, they're down with the posters, and those posters there's a set of posters that we can observe today, and there'll be another set of posters tomorrow. So these posters are only up, and we'll return at 2 o'clock, and then thanks again for a great session. Yeah.
Recent years has been 454 work, but goes back before that, of course. And you might say that I come from the simpler end of the repertoire spectrum these days, because my work has really been with unsorted B cells, humans PBMCs, and mouse splenocytes. But I want to start by going back before high throughput sequencing to tell you a little bit about a study that we did back in 2008. Some of you might know, but I think it's very relevant to our discussions at this community meeting. Because back in 2008 we set out to evaluate the IMGT human functional IGHV repertoire. And there were 226 V genes in the functional repertoire at the time. So we defined a spectrum from certainty to doubt. There were 4 levels in the spectrum, but that's not important here. Oh, that's right. The web. Yeah, sure. For certainty, corroboration was essential, and we also looked at functionality by looking for VDJ rearrangements in a database that we put together from public sequence databases. And we were quite proud at the time to find 4,718 sequences. The doubtful sequences had many different characteristics, but the two that I'd like to highlight are the last two that are shown here. We set out to determine where sequences had come from, and I'll have a bit more to say about that in a moment. And we also looked to see if there was a publication that described the work, and if there wasn't, our doubt pretty obviously grew. So we determined that 104 of the 226 IMGT functional IGHV genes were reported in error or included in the repertoire in error. Subsequently, about a year later, we found that 4 of those sequences, in fact, are occasionally found. So we revised our number down, but I would still maintain that 100 of those 226 sequences should be removed from the repertoire. So to illustrate our process of identification of the doubtful sequences, maybe we can turn to this question. Is V330 the most polymorphic human gene in the IGH locus? So most of the V330 alleles were reported by Ollie, who in 1995 published a study where he described V3 family sequences. And when subsequently the IMGT group organised a naming system, they named 16 of Ollie's sequences as alleles of the V330 gene, or perhaps the V335 gene. So the answer to my question is that V330 is not the most polymorphic gene in the locus, and the reason why I can say that quite firmly is that the 16 sequences that Ollie described all came from a single individual. Now, in fact, if you go back and you read that original publication, you find that Ollie said as much in the publication, writing that most of the differences between the sequences probably represented PCR artifacts. So, you know, unfortunately, IMGT did a great thing by bringing all the sequences together, but of course they separated the annotations or the commentary from those sequences, and people don't turn back to the old literature. So this very firm comment of the quality of the sequences was lost. I'd also like to mention the J locus. So those sequences, many sequences from the J locus, were described even earlier by Revech in 1981. And the locus was sequenced, and the 6 genes were identified, and they later came to be called by IMGT J101, 201, 301, 401, 501, and 601. But I'm interested in whether anyone here has ever seen J301, 401, 501, or 601, because I haven't. And so they either are very rare or they don't exist. And I would like us to decide, I guess, because somehow it particularly offends me for the O1 alleles to be so problematic. Of course, the sequences were described in the pre-PCR era, and so, you know, I'm amazed at what people were able to do then, and it's not surprising that there are some errors there. But you know, so are they real or not? Well, or are they rare? If they're rare, would you really expect 4 rare genes to be sitting there together? Would you expect 4 rare genes to be linked in this way? I don't think so at all. I think that those sequences should be removed from the repertoire. There's another issue that I'd like to briefly raise, and that's an issue that's illustrated by V4408. So this is an IGBLAST alignment of V4408 against the IMGT repertoire. And here we see 4407 with 7 differences to 4408, but there are 4 V459 sequences that are more similar to 4408 than 4407. And then we see more 459 alleles, 461 sequences, 438-202. There's all sorts of stuff down here until finally, way down the bottom here, we see 4402 with 21 nucleotide differences. Now, V4401 got its name because the 4401 was mapped by Honjo to the 3' end of the locus in 1991, and subsequently he mapped in a later study he mapped 4407 to the same position. So those 2 sequences came to be given those names. 4408 is similar to 4407 and got its name. The other 44 alleles are similar to 4401 and got their names. But 4401 and 4408, for example, there are 25 differences between them. And as Shishi mentioned to me over lunch, there's an indel difference between them too. So 4408 highlights the fact that lots of sequences in the IMGT repertoire have been named because of their similarity to other mapped sequences, but they haven't all been mapped by any means. So I now want to move on to describe some of our sequencing work, starting with our 2011 study of Papua New Guinean samples. And the polymorphisms that we went on to identify came from 4 samples, 2 individual samples and 2 pooled samples from 4 individuals. And we had about 47,000 reads. This was 454 sequencing, and we had a problem with gaps, and we were in search of germline genes, and so we filtered on the basis of the presence of 4 forward and 4 reverse reads in our data set, and that eliminated 24,000 unique sequences, leaving 332 unique sequences. So you might glance at that and say, pretty dodgy data, but in fact it was serving our purpose. We were looking for the germline genes, and this in some respects might look like an inefficient way of going about it, but it certainly beats cloning and sequencing as a means of identifying new germline genes. That really is a nightmare. So the 332 unique sequences went on to, our analysis showed that there were 17 new sequences in addition to previously reported V genes and pseudogenes. And so the 17 sequences included 6 allelic variants and 1 sequence that IMGT agreed was a new gene because of its difference to other sequences. I think Murray Paul regrets that decision, but that's not important. 17 new sequences, and our confidence in those sequences can partly come from the fact that most of them were found in multiple samples, and in addition, 6 of the 17 we found identical sequences in GenBank, and there weren't so many sequences there in those days. So I'm very confident in those 17 sequences, and I think many of you have seen them in the years since. So, but let's now move on to a trickier subject, and is there a place for cDNA-derived inferences of antibody genes? And, well, I think that we have identified many, and of course Tiger, or is it Tigger? Tigger, you say potato, I say potato. Anyway, so Tigger makes the process of identification of polymorphisms much easier, and I'm convinced that this is the way we're going to find new polymorphisms for years to come, until the game changes completely, really. So now, to illustrate the strength of the evidence behind cDNA-derived sequences. Although we've found human sequences, I want to turn to the mouse and some mouse work that we've done over the last couple of years. So last year we reported a study where we looked at C57 and BALB/C VDJ rearrangements to infer the germline V genes. And what you see here is just a small part of a large Excel spreadsheet, a pivot table, and we're looking at alignments to 9 different V genes, and the pivot table is showing the number of mismatches in different alignments between our sequences and the germline sequences. And the ones you see, the blocks in orange here in the column with no mismatches, these orange cells highlight the genes that we concluded were present in the C57 genome. And so just to dwell for a moment on V112, so here we've got 164 VDJ alignments that are perfect matches to the germline V11201 gene in the IMGT repertoire, which is documented as the C57 gene. Now, 123 is perhaps interesting because we found one instance, a perfect match to that sequence. It's defined as non-functional by IMGT, and I guess it is pretty non-functional, but whatever non-functional means, it looks like occasionally one slips through. If we turn to the BALB/C mouse, one glance at the slide shows how different this is. Down here, again, we see one orange cell, a bunch of sequences, 36 sequences with no mismatches, aligning perfectly to V12002. That's a gene that is in the IMGT repertoire and is annotated as a BALB/C gene. Let's focus on this cell here. So there are 381 sequences that we found, VDJ rearrangements, that aligned to V11401 with 2 mismatches. And if you looked at those mismatches, the mismatches were the same in all the 381 sequences. And those sequences used a whole range of D and J genes, and they had a whole range, obviously, of N-nucleotide additions. There were 381 independent pieces of evidence in support of our claim that there is a gene that is like V11401, but that is not V11401 in the BALB/C genome. So obviously to conclude what is a BALB/C gene and what isn't, you've got to have rules to guide you. In this case, what we did is we calculated likelihoods that particular sequences would arise by mutation from similar sequences using a model of the mutation process involving mutability of different nucleotide motifs, something a little like TIGR. And we also required that any new putative BALB/C gene should also be present in an independent data set, and that independent data set came from Sai Reddy, Illumina data from Sai Reddy. So let me summarize what we found. So we tried to document the full set of C57 genes as a demonstration of the reliability of our inferences. And we found 99 V genes that we felt were present, 97 of which are present in the IMGT repertoire. The 2 that aren't present, in fact, were reported by the Johnson assembly of the C57 locus, and those 2 sequences are present in an alternative database that I'll come to a little bit later. There were 12 sequences that we didn't conclude were present, or we couldn't conclude were present, sequences that are defined as functional by IMGT and that might be functional, but if they are, they're present at a sufficiently low frequency that we couldn't be certain that they were there. When we look at the BALB/C genome, we identified 164 V genes, and only 82 of them were in the IMGT repertoire. At first we thought that we'd identified 80 new polymorphisms, but subsequently we looked in the VBase2 database and the NCBI dataset, and we found 48 of the missing genes. But still, at the end of the day, we identified 34 sequences that we think are previously unreported BALB/c genes. Now, what is particularly important, and if we're thinking of nomenclature, for example, which has been touched on, here we see overlap between the BALB/c and the C57 genes. So there are only 5 sequences, I shouldn't say genes, there were only 5 sequences that were found in both strains of mice. And the divergence between the two data sets is so great that I really doubt that even when we have the BALB/c locus at hand, that we'll be able to find a correspondence between these genes. So to expand the story a little, we have recently looked in the nod mouse. The data set's very small, so this is not a comprehensive view of the nod locus. But the findings are really quite curious and add to the story. I think they certainly add to the story of the nod mouse. Because all the genes that we've identified have previously been found either in the C57 black 6 strain or in the BALB/c strain. That was a complete surprise to me. 4 of the genes are shared between the 2 strains. So 4 of the 5 shared sequences that I mentioned before are also present in the nod mouse. So no previously unreported polymorphisms. The nod mouse is said to be derived from a spontaneous mutation that arose in an animal in a colony of mice that are described as outbred ICR mice. And I've been able to find no further information on the ICR colony. But I think that these data suggest that in fact the colony was founded with BALB/c and C57 mice. The other thing to note is that there are 6 genes where we see both so-called alleles in the nod mouse. So 9301 and 02, 11201 and 02, and a bunch of others. So let's just return to the inferred BALB/c sequences. And so we've got these 34 inferred sequences, and these won't be accepted by IMGT because they're cDNA derived. But this is in fact a new rule. And the IMGT repertoire currently includes cDNA derived sequences and sequences derived from genomic DNA, rearranged or otherwise. Well, rearranged or where that's uncertain. So there are a couple of V genes, human V genes, and a few kappa J genes that are cDNA derived, and a number of others that are possibly from rearranged genomic DNA. And in the mouse, as you see here, a huge number of mouse V genes are derived from genomic DNA that could be germline but might be rearranged. So I've mentioned the fact that we've identified many sequences that we think are for real. Where can you find them? So let me introduce you to our small database, the IGPDB. And the first thing that I have to tell you is that if you enter that into a Google search, this is what it will take you to. Now, I think we had the name first, but they obviously get more traffic than we do. So if you want to find the IGPDB, you need to enter some other term, unswig, immunoglobulin, IGHV, and that will take you there. So I've got to say that the database, if some of you might have tried to visit this database and it's been down, there hasn't been a lot of interest in it. It was built and is maintained by Bruno Gator, a colleague of mine at the University of New South Wales. And if people aren't interested in the database, well, of course, it won't be maintained. So I hope that if there is some enthusiasm from this meeting for it to be developed, for it perhaps to be expanded or transformed in association with other people, I'm sure, well, I know that Bruno would be very interested in that. There are a lot of sequences in here. About half of them have come from Bronwyn Lamson, Catherine Scheepers and Lynn Morris, the South Africa group. As you can see, there are some genes that have many alleles. I've just pasted over the top of a screenshot of the database. So you see down here, 15 previously unreported alleles of 169, and pretty amazing, 170 sequences overall. So the database that we think of when we go partitioning VDJ rearrangements is now so hugely different to the IMGT database. There is a reasonable amount of data within the database on the reported polymorphisms, but I'm sure this meeting would hope that there would be more, and perhaps that can happen. The IGPDB website is also a means by which you can get your hands on the repertoire that we believe in, although I have to point out that I tried to download the repertoire last night and I couldn't. So again, because there has been no interest in this, so please express your interest. I'll convey it to Bruno, and when Matt Solon contacted me, I think it was 3 days ago, to say that he couldn't use the database, I emailed Bruno, and in half an hour it was up and running. But let me just introduce you to a couple of other issues. So some of you will be familiar with the VBase2 database, which was built by Werner Muller. It hasn't been maintained since, I think, 2006. But an interesting thing about his database is that he has a classification system. So class 1 sequences have been identified from genomic sequences and have been seen in rearrangements. Class 2 sequences have been identified from genomic sequences, and class 3 from rearrangements. I would probably, if this is an ordering of certainty, I'd probably flip the 2 and the 3, because I really believe that one genomic sequence from the distant past is no match to thousands of cDNA-derived sequences coming from multiple individuals, from multiple independent studies, from different parts of the world. I also want to highlight the nomenclature that Werner Muller used. So he assigned consecutive numbers. As each new sequence came in, he gave the sequence a new number. It means that this is not a positional nomenclature, which gets us away from the problems that Corey has inflicted on us. No. I mean, now that we know of the structural variation, it is so difficult to continue with a positional nomenclature, I think. But it's true that the positional nomenclature, well, one, it's done a great deal for us over the years, and two, it does provide important information at a glance, or we hope it's important information at a glance. If we see two sequences with similar names, we can be reasonably confident that they may be two sequences from the same locus. So we might be looking at a heterozygous individual if they have these two 169 alleles, for example. That's probably a bad example. Okay, look, to conclude, I'd also like to emphasize the fact that I think that repertoire studies are about to change. In fact, they already are changing. As more and more people are taking on high throughput sequencing, other people are are beginning to look at repertoires, and I think evolutionary studies are going to be important. And I'm very keen to see those studies go ahead. I think that we've got a lot to learn from comparative studies, and one of my current interests in the mouse is to see if studying the mouse repertoire ultimately will tell me something about the human repertoire, because I think that the mouse repertoire is designed to meet the needs of the mouse, and as I get my head around that fact, perhaps I'll develop some ideas about the human repertoire. But so let me talk about the platypus, because, well, the platypus genome was sequenced in 2008, and given its importance in the tree of life, this was a significant publication. But what happened here is happening with many species, and the elephant comes to mind. A reference genome sequence is published, and people then say, okay, let me go and look for antibody genes. And publications have come out on the elephant. And there is a set of platypus IGHV genes in the IMGT database which are derived from an analysis of this draft platypus genome. So I guess I hope that another thing that this community can do is perhaps spread the word to the wider sequencing community that that's not the way things should go. And I think that we've learned lessons from the human and the mouse about the problems that come when gatekeepers give a stamp of approval to a sequence. We then stuck with it, perhaps not for all time, but it becomes very difficult to revise. So I hope that not too many of these studies proceed before that message goes out. I just thought I'd finish with this slide, which is in a sense a completely different topic, but I am supposed to be addressing minimum standards and what information should we be providing on our sequences. I guess I've been inferring things from sequences for years now, and the latest thing I've been trying to infer is antibody isotype function, in particular IgG subclass function. And so this is a paper that Catherine Jackson and I produced a couple of years ago, where we're trying to suggest a new model of IgG subclass function. And why I mention it is that we've known about subclasses for 50 years, and subclasses were talked about for a while, but they don't get discussed much these days because we couldn't make much of them for such a long time. And I think if we are to make something of them, we need more data telling us about the sequences that are being expressed as the different subclasses. So a field in our minimum standards document, perhaps I think it already says isotype, but let's not leave that at IgG. If you're producing IgG sequences, let's see if we can get the subclass too. I should perhaps just say I've got a paper in review at the moment where I'm trying to do a similar thing with mouse sequences. And I should say it's a completely different model. So let me just finish by acknowledging those who've assisted, and particularly Catherine Jackson, who's been critical to all of the work that you've seen here, and also Yan Wong, who's also here today. And I'll also particularly acknowledge Scott Boyd, who's been generously sharing his data with us since our first publication, the genotype paper in 2010. Thank you.
So something I've thought about for a long time is this idea of assigning functionality to genes. You obviously talked about an example where you found a gene that IMGT says is non-functional. So do you think it's irresponsible to even attempt to do that with what we know now? I mean, obviously 169 is functional, but for a lot of these genes that IMGT currently calls non-functional, do you think that's
that's reasonable, and if not, what would you propose we do?
Yeah, look, well, perhaps my answer should speak a little wider. I think, I'm interested to see people genotyping, that is documenting all the different genes in an individual, and the sort of thing that we've done over the years is to try and document the percentage utilization of the different genes. And I think that ultimately we're going to find that different individuals will utilize different genes at different frequencies. And it may well be that some people, some rare individual will have one of these sequences that in most of us is non-functional, but in some individuals is working for us. And a wider issue actually is, I think these rare sequences are interesting. Why are they there? If it is at that relatively trivial level, just a sort of something sneaking through, perhaps it doesn't mean much. But the spectrum of utilization of the V genes over what, maybe 4 orders of magnitude in a reproducible fashion is something I think we've really got to get our heads around. Not only why are the frequently utilized ones frequently utilized, but why are the rarely utilized ones still there?
So the next speaker is Christian Busse from the German Cancer Research Center, and he will set up his computer first, and then he will speak about single-cell data, which he gathered in the recent years.
Do you have an HDMI port?
Sorry?
Do you have an HDMI port?
No. Okay.
Oh man.
So do you have another kind of?
Yeah, I don't know if this goes for
no, because that's up. Okay. Do we have a USB stick?
I'm sorry?
Do we have a USB stick?
I can get you go find it.
USB stick?
Yeah, I can go
Because
find it.
okay, sorry.
I spent a lot of time thinking about what genes to include in these sorts of germline databases. Do you think it's possible to fully automate that sort of process, or do you think that there's always going to need to be some human curation? I mean,
No.
Really louder. Okay. So Andrew's obviously thought a lot about how to include germline genes into databases, and I was curious, he thought that you could come up with objective criteria that could be automated in order to decide which germline genes, or is it always going to require human curation?
Look, that might, I might not be the best person to answer that because I've thought constantly about these genes, but I'm not skilled in IT, bioinformatics. So I've never thought about whether it could be automated. But I will.
Okay. So sorry for the delay. It's just that there's one slide where Microsoft ate up my pictures, but I guess they'll all be capable of comprehending what I'm talking about. So thanks, Florian, for the nice introduction, and the organizers for inviting me. My talk today will be basically split up into 3 parts. So first, since I'm here as a member of the single cell faction of our community, I would like to talk about general properties of the various platforms that are available in the field that give us some amount of single cell resolution and their advantages and disadvantages. Then I would like to switch gears and use data from our own lab, which in this case comes from a controlled human malaria infection trial, to illustrate some of the advantages that full-fledged single-cell analysis has for us to understand biological questions / raise new biological questions, as you will see in the end. And then in the last couple of minutes, I would like to then talk a little bit about interfacing single-cell data sets with the standards that we are proposing here, which is what I just called supply and demand, so both from the side how a single-cell researcher can get or what he needs in a bulk data set, and on the other way around, how single-cell data can be contributed to the community. Okay. So let's start. So I took the liberty to come up with 3 categories of technologies that give us single-cell resolution. So the first one is what I call here stochastic pairing. These are basically all technologies that are still doing bulk sequencing. However, their bulk pools have a size that is smaller than the inverse frequency of the expected clone size, so that therefore they can later on, so on average they will have less than 1 occurrence of the clones that has been looked for, and they can infer heavy and light chain pairing. Then physical linkage, this is a methodology that most of you will know coming from George Giorgio's lab. So here the cell suspension is compartmentalized at some point during the processing, and each compartment on average holds again less than 1 cell, and then within these compartments nucleic acids encoding heavy and light chains are physically linked into one amplicon, which is then, after compartmentalization is broken up, processed in bulk. And then finally, complete separation. These are technologies that currently exclusively rely on flow cytometry to provide us with single cells, and then once the sort is done, this single cell context is maintained throughout the whole experiment. So now talking about the various features that we have that would distinguish single cell experiments from pure bulk experiments. So first, about chain pairing. All of these methods were primarily designed with chain pairing in mind, so all of those can do it. However, it's important to keep in mind that for stochastic pairing, this only works, of course, if you have an expanded clone. Otherwise, you're basically doing a bulk experiment. So therefore, also I added this asterisk for the 2 down here, because that means it only applies to the expanded clones, not to the other ones. Okay, well, physical linkage and complete separation, of course, provide you with this kind of information. Now, primer and expression bias, I think this is something we will hear more from Sai later on, is the main issue, whether basically about normalization of the reads that we get from a platform versus the cell. This theoretically is possible to do with a stochastic pairing if there is only 1 cell. Same thing, so also for physical linkage, there are a number of ways. They're usually trying to do normalization, so limited number of capture beats, linker primers, and so on. And finally, for complete separation, this is rather easy, because here your single-cell PCRs usually run into saturation, so the amount of a template that you get out for sequencing is very limited. Then single-cell consensus, so this addresses the ability to build a consensus sequence out of the sequence that you get.
and thereby apply error correction on this level. This can work for stochastic pairing. It theoretically is also possible for the physical linkage. However, there it does require that you actually have a singlet because there is no cell identifier in this context. But basically, cell identity has to be inferred from the BDJ rearrangements. For complete separation, we can simply do this based on the well level. Linkage to flow cytometric data on the single cell level is something that can be quite powerful, as I hope I can show you in a minute, since flow cytometry is just a very prevalent technology for immunologists, and we will have a lot of data to compare it to. However, since both stochastic pairing and physical linkage are basically bulk technologies at the point of flow cytometry, this only works for the complete separation. Finally, preservation of material, of actual single cell material, is also only happens in the complete separation protocols. There you typically have a little bit of cDNA left, plus you have the intermediate stages. For cDNA, this is very handy if you want to do cloning and expression of antibodies later on, because you have a template to go back to and you don't have to rely on synthesis. So these would be the technical parameters. Now briefly through the more administrative stuff. So stochastic pairing has, of course, good throughput and is rather doesn't have a high cost besides the sequencing, and it should be readily available because it's basically an off-the-shelf technology. For physical linkage, so this is truly a high throughput technology that can process 250,000 cells in a single experiment. So there it's for this it's extremely powerful. The costs, I've actually issues in estimating. Probably should ask Brandon about that, but I assume that it's actually not higher than for the stochastic pairing, or might be even lower if you design the experiment correctly. The issue here is that in terms of availability, these technologies typically require some kind of encapsulation device that is currently not commercially available, and depending on whether you're an engineering department or not, that might prohibit you from doing this easily. Complete separation, finally, I would not dare to really call this a high throughput technology anymore, because what we can do is 10,000 cells. That's relatively easy. 100,000 you can do, but it becomes rather expensive, since the main issue here is the high cost associated with it, as you will again see in a minute. Finally, availability. Most of these things are off the shelf, but if you want to go for intermediate throughput, you need an automated liquid handling, which you can buy off the shelf, but it's nevertheless a 6-digit number in your budget. Okay, so I hope that this is enough to give you some overview on what single-cell technologies we currently have. Now, as I said, I would like to move on to work from our own lab. So here, some of you probably will be aware of the platform that we have, which falls into this complete separation category, and which we call matrix single-cell PCR, since we are using a two-dimensional array of tagged primers to encode the spatial position of the individual cell in a set of plates, so that we can later link all of our information back to this. So the platform, as we have it currently in productive use, has a processing capacity of approximately 10,000 cells per week, with a processing time of roughly 10 days to 2 weeks. Cost, I usually quoted that as €1 per cell. I recalculated that yesterday, so with the changes in exchange rate, it's now €125, but I guess that's still in the same order of magnitude. We completed our switch to Illumina since 454 has been discontinued. We're basically the final stages to complete the setup to perform also mouse TCR experiments on that platform, and we're working to get a proof of concept to perform the cloning and expression in an automated fashion. Okay, so now what can we do with this? So these are actually, okay, so these, whatever starlets down here, please ignore them. So mainly what we are doing is, in collaboration with the University in Tübingen, we have controlled human malaria infection trials, which means that we have malaria-naive subjects, which are healthy Europeans who have never been exposed previously to the causative agent of tropical malaria, Plasmodium falciparum, who are then put under antibiotic protective coverage with using hydroxychloroquine and stay under that coverage throughout the trial. This means that HCQ kills the parasite once it moves into the aerosolicitic stage, so therefore people never really become sick, although we infect them with a live pathogen at the points that are indicated here. So this is a prime boost scheme with 28 days between the individual injections, which are IV. Then we sample always 7 days after the injection, which is then labeled time point 1, 2, and 3. And what we're then going for is we are sorting from the PBMCs derived here both cells that have a plasma cell phenotype, plasmablast phenotype, and cells that are antigen experienced, so memory, and bind CSP. CSP is the circumsporozoid protein. This is the major surface antigen of the of Plasmodium falciparum at the stage that we injected, and so that's basically antigen-specific enrichment of our cells. Now, when we do this, then so these are the 3 donors that we're looking in here. Then what we can observe is that clonality in the response actually increases over the 3 injection time points in all 3 donors. There's one donor that has a lower or that has oligoclonal dominance, while the other ones are rather diverse. Now, if we then ask or basically go back onto the index sorting data and ask, okay, so now for one of those individual clusters, so which is a set of clonally expanded cells, where do we actually find them back? Then interestingly, while at time point 2, they are still, so this is now for one of them as an example, while on time point 2, they are still distributed between the plasmablast and the CSP memory compartment. At time point 3, the vast majority of them actually locate into the memory compartment and seem to not have an activated phenotype at this point. So we then went further on and asked about the true reactivity of these cells, so actually proceeding further with clonal expression of the antibodies, and then assayed the monoclonal antibodies that we got out of this versus in a CSP ELISA, so versus CSP reactivity, which is basically plotted on the y-axis here. Now this is plotted against somatic hypermutation patterns or simply somatic hypermutation counts in here across the different time points. Now, interestingly, while at time point 1, you observe that, number one, hardly any of those antibodies has a good reactivity. There are basically 2 populations. One that is shows hardly any mutations, while the other one is rather high, already has a intermediate to high mutational pattern. While if we then look in the later time points, we actually find that the number of really highly mutated cells actually decreases, while we now see a strong increase, especially at time point 3, of hardly mutated cells that are mostly IgM, which have a very high affinity. Okay, which for us, of course, raises a very simple question. So if these are mature naive cells that are recruited into this response, they should have been already around at time point 1. So what is actually the mechanism that prevents them from going there? Okay, so and this is what I said is basically the new biological question that this experiment raises for us. To add it, I mean, other people have seen similar things. Tom's lab has done a study with anthrax. There has been a recent paper on hepatitis B that suggests similar things. So we're probably not the only ones who have encountered this strange phenomenon. Okay, so then, as I said, the final couple of minutes, I would like to go through how we can interface single-cell data with the standard that we proposed. And here, so I'm starting with a demand as a as a single-cell lab we would like to find or be provided with from the community. So I think what is important to have that is documented is transparency in the material flow in an experiment. So this is basically cell number and a quantification of nucleic acids that are used at the various steps. Since, I mean, for single cell, you know, okay, cell number is always 1 and you're pretty much using all of the material that is available in terms of amplification, and then it's a binary yes-no decision. But otherwise, so to make a sound judgment about detection levels, these two parameters are important. Then the next thing is that I would like to stress is, of course, information on cell population and purity. Single cell has the advantage that basically it's very hard for you to get a contamination. I mean, if you contaminate something, then you contaminate a single well. Doesn't really matter. If you're doing bulk sequencing, of course, a single cell that doesn't belong to your gate can actually lead to a misclassification. So therefore, I would like again to stress that I think it is important that we require people to report not only their free text name, what they think or what they think how the population should be called like, but actually to deposit row flow cytometric data, which can simply be recorded during sorting. Okay, if you want it, your operator simply clicks a button and that's about it. I don't think that this actually should put a heavy strain on de novo studies at this point. Okay, then finally, in terms of supply, so what can a single cell or a single cell lab provide to the community? I think, of course, that this type of data, although it's not as deep due to the possible linkage, can be interesting for verification of different studies. And so therefore, the most critical thing is how we want to be able to annotate chain association, which would be point number 1, and how to link additional, so non-sequencing data like flow cytometric data, antibody reactivity, and so on and so forth. And I think this can be solved in a rather simple way by simply saying, okay, we need some kind of cell index, which then links which can be annotated to the given reads, whether they belong or are inferred to belong to a given cell or not. Okay, so then finally, I would like to acknowledge the people who did this work. So Katharina is a very gifted PhD student who basically developed most of the pipeline that we use for processing. The malaria data that you saw is actually Gopal's work, and Hedda is the head of our division. We had a very fruitful collaboration with Max Planck for molecular genetics for the initial pipeline. And the study, as I said, was conducted at the University of Tübingen. And finally, so if you find yourself being on a sleepless night and want to do single-cell processing, then so the software that we released for that one is T-Raptor, and you can find it under this address. So thanks for your attention.
I have actually a very quick question to your time points that you have for your malaria study. And I pointed something similar out to Kate Zawatsky from Tom Cadwell's lab when she presented her work at the GRC. I often see that, sorry, they seem to be too low for people like me. Okay. So to repeat that, the time points that you were using for your malaria study were usually day 7 after challenge, right? And something that was published a couple of years ago was that an important part of the memory recall also happens at day 4. And do you have any data on that, how that looks like in your assays that you did?
So we do have, so there is a very tight sampling coverage. However, we have not yet looked into all of them. I mean, there is, we are also interested in looking at basically day 0 of injection, especially for time point 3, to see whether these memory cells are basically responding or are still around there. The thing is that for human studies, time point 7 for plasmablast proliferation seems to be, so this is a very narrow window. You can get also responses already at earlier time points, but that's slightly dependent on the pathogen. Okay, and here, since immune cells have to go into the spleen, then be recalled, and so on and so forth, we would have to look, but based on a lot of the tetanus studies, for example, where people are doing recalls after, so basically this is then the 6 or 7 recall that people are doing, there the time window is very, very, very narrow. So you sample at day 6, you don't find anything. You sample at day 8, you don't find anything. And at day 7, you really have the spike for plasmablast. So this was, so getting the plasmablast at this point was a focus of the study. If depending on how much memory or on how much we're interested in the memory thing, it might be worthwhile to resample at that point.
In your overview in the beginning, you make a plus for primary efficiency dash bias for all 3 methods, single cell based.
Sorry.
And I was wondering, yes, how did you stratify this? So
this one?
Yeah, expression bias. So in that sense, how do you know if you don't know the distribution of the cells you're analyzing? And most of this are based on primer families. So how do you exclude that? Let's say a primer set prefers one germline over the other, and you will just not end up with an amplicon.
Okay, so the thing is that in this for stochastic pairing experiments, either you detect the clone or you don't. Okay, so there you're basically generating, so for the individual pool, you're operating on a single cell context, okay, once you have detected this. So for physical linkage, as I said, so they often incorporate linkers into these experiments, so thereby basically, and those are already added in an earlier stage, so main amplification is done using these sequences. Okay, that doesn't mean that there is no amplification bias at all, but the question is just whether you really have this highly competitive situation that you usually would have in under bulk circumstances. Okay. Of course, we also, even with under the complete separation circumstances, we know that in the secondary PCR, you can see cannibalization between different products. So one comes up, the other one does not come up. If we compare this, so I had a recent discussion with Chaim about this, so the amount of transcripts that we find that are non-productive versus the productive ones, then it seems like that in majority of bulk sequencing studies, roughly 5% of the reads usually show non-productive rearrangements. While in our case, we find that approximately 20 to 25% of the cells, depending on the locus, still have, so we can detect expression of a non-productive rearrangement. However, now with the new high throughput sequencing, we know that also we are able also to detect this at lower levels. So it's not necessarily that one only wins and we wouldn't detect the other one at all, but basically we have 2 tiers or 2 ranks of consensuses that we can build.
All right, so our final speaker for this session is going to be Sai Reddy from the Swiss Federal Institute of Technology in Zurich.
Okay, I want to thank again the organizers for inviting me for a great meeting so far. So today, a lot of this presentation will be on developing standards and how we can use standards. I want to start by addressing or introducing something which you may already be aware of, which is this is an issue that's been solved by the RNA-seq community already, and it's the idea of using spike-in standards. So there's something called the External RNA Controls Consortium. This was a group of academics and industry-based scientists who came together, were hosted by the National Institute of standards and technology to basically build RNA standards. And what they created was a set of 92 pre-formulated polyadenylated transcripts, which were designed to be added to complex RNA mixtures. So, and these are all designed so that they would not interfere with the biological sequences. And they're added with different concentration ranges, and they're supposed to provide a calibration as a quality control for an RNA sequencing experiment. And they've been used extensively throughout since they've been developed. You can buy this right off of the Thermo Fisher website, including other sources. So they're really a powerful tool that RNA-seq has used and now creates a validation for their sequencing platforms. So one of our goals was to actually try to be inspired by the ERCC spike-ins and develop something similar for antibodies. And we started with using this for developing towards murine VH genes. Now, one of the easy ways to do this is you can just literally order synthetic antibody genes that are immediately cloned and sent to you in IDT mini from the vendor IDT, and they send you these into this vector. And this vector has a T7 promoter that allows you to just do in vitro transcription to generate your RNAs. We designed our spike-ins to have mouse VDJ region. If you look a little bit closer, we have, in this case, we created 16 different spike-ins, meaning that there's 16 unique CDR3 regions. We put in some designed regions of somatic hypermutation, and we obviously you can't cover the full diversity of a mouse V gene repertoire. It's so massive. So we just picked about 7 V genes, and one of the things we wanted to do is we wanted to have each V gene represented at least twice, and that's going to be important for addressing systematic bias in a minute. We also put in a spike-in identifier region, just a small synthetic area, which will allow us to separate this from biological data. A portion of the IgG constant region, so you could basically amplify this during a reverse transcription step with the same primer that you use in biological DNA. And we put a synthetic 5' constant region here. This is for single-plex PCR, and I'll show you why that's important later. This is, I guess, is probably a little too small for you to see, but that's just the construction of our spike-in. Okay, so what I meant by single-plex PCR is basically what you can do is you can do a reverse transcription here, and you can ignore right now that we add reverse unique molecular identifiers and forward molecular identifiers, but I'll come back to that in a minute. But you can do your RT step, and then at the point at which you do PCR, you can use single-plex PCR, meaning just a single primer because of that synthetic 5' region that I added. Normally, if you had to do multiplex PCR, that's not an option, of course. And then you go ahead and you just add your adapters through extension PCR steps, and this would be set up for doing Illumina-based sequencing. So we did this, and we started with this with these RNAs that we mixed together, and we mixed them together so that they actually spanned a concentration range, so they're not equimolar. We wanted to kind of mimic how a repertoire should look. So they spanned an 85-fold concentration range. We made 5 replicate libraries, so from the same starting RNA, we made 5 separate cDNA reactions and PCR reactions. And then we went ahead and we did Illumina sequencing, and each data set is about 300,000, a little bit more than 300,000 sequencing reads. And you can look here at the frequencies of each spike-in, and you can see there actually are error bars there. They're very low. It means that single-plex PCR introduces very little error. That should be kind of obvious. The only error is from stochastic PCR. And you can also see that if you use the read count or the unique molecular identifier count, you actually come up with very similar frequencies. So this actually just is our starting master pool so that for validation. So the next step is when you actually add this into biological material, one of the things you have to be very careful of is, well, I don't want to spike something in and have it overtake my biological sample. That would be really annoying if 50% of my data was just controls. So we developed an approach by using droplet digital PCR, and this is a method of actually counting unique molecules. And we coupled this to qPCR so that we would know that we would always amplify products in the linear range of PCR before we saturate, and that's really important for not creating chimeras. One of the really important things about if you're ever going to use unique molecular identifier tagging or any kind of sequencing is I would really advocate the idea of doing ddPCR because having a unique molecular count is critical. So this allows us to essentially know the exact molecule count of our biological sample and spike-in sample, and essentially we always put in about 10% of our material as the biological, or as the spike-in. And of course we can make this lower if we wanted to. And another really important thing here is the number of cDNA molecules that we have, spike-in and biological combined, we can count, an actual count, 100,000 molecules. So when I go to get my sequencing reaction done, I better calibrate this to try to get at least 1 million reads. So, because I want to over-sequence everything. If I undersample, I won't be able to do any of the sort of error correction type of things you might want to do. So we calibrate that very carefully. Okay, so here's what you can do. Because we have these 16 clones that we know the exact sequence from, they're synthetic, and we know the concentrations that they're at, we can assess things like errors and bias. When you look at errors, we started with 16, and this is data on just the CDR3 region alone of the 16 spike-ins. I do acknowledge that this is a bit of an overkill data set because it is 100,000 reads on 16 clones, so you are kind of, I am making it is more dramatic than maybe it might be in reality, but you can see that this is one of the clones that's actually at a lower frequency, and there are 24 versions in the CDR3 region alone, 24 somatic, or let's say artifact variants. And then here are the variants across all 16 spike-ins, and to no surprise, as a spike-in is present at more frequency, the more number of errors that you get, more false positives. If you look across the VDJ, the situation looks more dire. You go from a single spike-in, actually in some cases shows up at 5,000 different variants in the VDJ locus. So here's the VDJ of this clone. So every sequence in our data set with that CDR3 region, there's 178 variants. So if you were trying to make error like trees and model the evolution, you're really just modeling the evolution of your error from PCR and sequencing. And you can see the same results here from the spike-ins of the VDJ can follow the trend of the more frequent something is, the more errors that you get. Okay, so how about bias? So that's not the only bad news. If you use multiplex PCR, so in mice, we use a primer set that has 19 degenerate primers that consists of 87 unique primers. And what I did here is I took my biological samples, the biological part of the data, which was mouse splenocyte cDNA, so it's just we kept it IgG, keeping it rather simple. And I looked at every single V gene that was annotated based on IMGT, and I looked at how many primers were associated with that V gene. So there are examples of some V genes that have up to 80 primers of this 87 mix associated with it, meaning that essentially, and of course this also correlates with frequency. So some primers just misprime like crazy, and they cause a lot of amplification bias. The primer bias also scales with melting temperature. That's actually not that surprising. And if you look at the mispriming here, you can see that not only are the degenerate positions varying, also positions that aren't even degenerate are varying. And this is because of this, they're so similar that they can always have some partial annealing and amplify. So I don't think the approach of just optimizing the concentration of your primers would ever work in this scenario. Okay. And thankfully, we're not sponsored by someone who would disagree. Okay. So how can we, another really fascinating thing that we can do with multiplex PCR bias is that we have a master pool of our spike-in RNA. Actually, we've turned it into cDNA based on the IgG primer. So we have this master pool, and we take one an aliquot from that, and we do single-plex PCR, and we have our frequencies here. And then we take that same master pool and we do multiplex PCR. So we know we have the same starting material. One is singleplex, one is multiplex. What is the influence of primer bias? A really unambiguous way to address this. And by just looking at the frequencies here, and these are replicate libraries, n equals 3 and n equals 5 for the singleplex. And you can see here, if these lined up exactly on the line, you'd feel very comfortable because it would then be no bias from multiplex. But an R-squared value of 0.56 is actually quite bad. It means that there is a huge amount of bias being introduced by multiplex PCR. And what is interesting is these are color-coded by the germlines in the spike-ins, and you can see the bias is rather systematic because it's always either above or below the line. Okay. Now, many of you are very familiar with unique molecular identifiers, barcodes, and it's typically a way that you single molecule tag your RNA or cDNA, and then you perform your next-gen sequencing and then error correction and bias correction. What we did that was a little bit unique to this approach was everyone in the field to date tags their molecules at the single molecule level. So we do that as well in the RT step. But we actually also tag during the PCR step. So this is actually tagging the amplification. So we call that amplification fingerprinting. And then we go forward with the typical PCR process. So the single molecule tagging allows you to do all of the error corrections that you have seen in other papers, like the work of Mikhail Shugai and Christopher Vollmers and everyone else in the field. But the multiplex, I'll just get to it in a second, sorry. The multiplex PCR also allows you to correct for, the forward identifier allows you to correct for errors in the molecular identifiers themselves. And then really importantly, it's really simple. We just basically plug that into the equation for exponential amplification of PCR. And that allows us to give a normalized count. So essentially, we normalize for amplification bias because every molecule is also being tagged during amplification with a barcode, and we can know what's being amplified better or worse. Now, this is I'm not really a pipeline builder, so I'm not going to offer any great software or anything. But this is what it looks like, and it is computationally intensive. But at ETH Zurich, at our university, we have a really great high-performance computing platform, which allows us to run through lots of data really fast. Now, just to show you the results, I'm not going to go belabor it because we have already published it. I'll just show you the main results. By doing this approach, we've been able to correct for, in the CDR3 region, 100% of the time of at least the examples that we showed, and that's for all 16 clones, or 16 spike-ins. In the VDJ region, we get about 98% error correction. We're not able to correct every single clone. My suspicion is that errors are introduced by the reverse transcriptase, which would not be possible for us to correct. The bias correction is really interesting because, so this was where we tried to actually optimize our primer set, and it made the actual correlation worse. But after we do this very simple normalized bias correction, you see that we start to achieve frequencies correlations of 0.98. That means we're actually achieving what you could get out of a qPCR assay from NGS, and that's really important for targeted sequencing. And if you compare it with the state-of-the-art published in this paper in 2011, which just counts the reverse IDs, we outperform that quite a bit, although that is pretty good, at least. It's not as though that wouldn't provide value. Okay, so just in case anyone's interested, we've also made spike-ins for the mouse light chain, and now probably nobody is that interested. What people might be very interested are spike-ins for human, and so we've partnered up with Novartis, Elisabetta Tragai from the Novartis Institute of Biomedical Research, and what we wanted to do, and this is why we actually sought the support of an industry collaborator, was to make a really definitive large spike-in panel for human, meaning at least, Andrew's talk notwithstanding, we picked 48 germline gene segments, 85 unique CDR3s. Each spike-in is about 350 for each gene, so this is a significant cost. And we put them at different frequencies based on a paper from Remy as well as from Scott Boyd. And so these are all mixed, these 85 unique spike-ins, 48 germlines, and we go through the same process, but we do some interesting things. We actually add a leader sequence. So some people, if you want to adapt it to use leader sequences, you can. We also add isotypes IgG, IgA, and IgM. And here is just some, and we designed our spike-ins so that these are the CDR3s, and the main point here is that the distances for all of the CDR3s, we actually made sure they had enough Levenshtein distance with one another, so they're not like, you're never going to confuse one spike-in for another based on the way we've designed it. Here's our first set of runs. We did n equals 5 singleplex and multiplex amplification of our spikings. I'll just show you the singleplex. From a data set of about 300,000, even though we started with 88 unique CDR3 or 85 unique CDR3s, we come up with 22,000 or almost 23,000 unique CDR3s. Here's one of the lower frequency CDR3s, and there's 48 unique variants. here's the singleplex versus multiplex plot, and you can see the R-squared uncannily is 0.56. Even though we've moved from mouse to human in different primer set, multiplex PCR bias still introduces about 40% bias in this human system. Here are all the V genes that we've that of our spike-ins, and they're actually, some of these are of the same family, and so we actually find that it's rather systematic bias, or at least regularly underrepresented and overrepresented. Okay, so before I move on, I wasn't going to present this until our discussion yesterday, and the idea of moving from molecular to cellular spike-ins. So what about, like, this is fine for bulk sequencing, but what about people who want to do paired sequencing? What about people that want to do 5' rays? Our spike-in approach would not be compatible with that because there's no UTRs. So what I'm going to show you is how we've developed this, something that wasn't made for spike-ins on the cellular-based level, but could easily be adapted to that. So the actual motivation was recombinant protein antibody expression. So if you are in a lab and you want to actually make an antibody, you actually have only really one option, and that's transient transfection. You basically have to transfect your plasmid, expand your cells for a bit, culture supernatant, and get IgG. However, if you were going to manufacture antibodies, you can make a stable cell line, which takes 6 months to a year, and is very laborious, but then at least you have that cell line forever, and it's really useful. But that's not typically accessible for most academics. And when I was a postdoc, I had to do tons and tons of transient transfections, and so I was motivated to try to inspired to try to do something that would be a lot more easier to make stable cell lines. Actually, I didn't do the work. A brilliant grad student that worked under me did all the work, who's in the audience today. So I thank him for inspiring me with all his hard work. So the point is, can we make faster and cheaper ways to make stable cell lines? So hybridomas, many of you know, of course, are a great platform for screening and discovering antibodies, but they're also a great way to produce antibodies. Hybridomas have some important properties in that they surface express and secrete the same antibody because of alternative splicing. And there were efforts, very classical efforts, to engineer hybridomas, work done by Mark Baker and also Perry Fell from the late 80s, where they engineered the constant region of hybridomas using positive-negative gene targeting, laborious methods of homologous recombination, which tend to be pretty inefficient. Now, unless you've been in a coma for the last 3 years, you're well aware about CRISPR-Cas9 and all of the things that it's revolutionized with genome engineering. And as you know, as you probably know, Cas9 is a bacterial enzyme that's programmable by RNA-guided nucleases and able to cut specific portions of the genome where you could knock out genes or knock in genes. And so we just thought, let's be inspired by the old methods and then all these new tools, and can we just reprogram hybridoma specificity to create really fast sources of stable cell lines. Another point about this, besides just spike-ins, is that we generate so much next-gen sequencing data, but then the bottleneck comes to if you actually ever have to express an antibody and validate it. So the idea here is actually first to make a reporter cell line. Take a hybridoma expressing an antibody and make it express a fluorescent protein. So the reason why is then you can see, if you then turn it back into an antibody expressing cell, the loss of fluorescence. So we go into the heavy chain locus of a hybridoma clone that we've characterized. We replace the variable heavy chain with an mRuby, which is a red fluorescent protein, and then has a stop codon, so it won't splice with the IGH region. So here's our wild-type cells expressing IGH, no mRuby expression. Here's after transfecting it with Cas9 plasmid, along with our homology donor with mRuby in the middle, exclusively expressing mRuby. And then we can validate it by RNA and genomic DNA assay. Now, what we wanted to do, again, this was not for making spike-ins, was actually to find fast ways to express monoclonals. We delete the light chain. So we just go in and we had 2 CRISPR sites flanking the light chain to just delete it. So here's our wild-type cells expressing light chain and heavy chain. Here's our mRuby cells that we've deleted it. And this gel shows you that. Now what we can do is once we have a hybridoma expressing a fluorescent protein in the heavy chain locus and no light chain. And what we're going to do is just introduce a synthetic antibody gene, which is just a light chain with constant kappa, and then it has has the 2A splice peptide, which means it can essentially, from the same promoter, express 2 chains. It has heavy chain with a splice site, so it should splice with its native promoter. So a single transfection with CRISPR-Cas9 and this homology donor should lead you in the genomic locus to have this, which is light chain, constant kappa chain, and variable heavy chain spliced with that, and make a full-length mRNA transcript. So we used an antibody that was against a model antigen Hennig lysozyme to do this, and this just shows you after doing the transfection, we sort a small population here, and you see that you have now the mRuby cell line has completely been transformed to an antibody-expressing cell line. Because these are hybridomas, the great thing is they also secrete antibodies, so we can actually just harvest the supernatant if we want to use the actual protein itself. And so this means that you can essentially go and make a stable cell line for antibody expression in 1 to 2 weeks. It's just a single transfection step with Cas9 and your donor plasmid, and a single screening step to isolate your cells. So the point about how this can be used in the future, we believe that we could eventually use this for a surface display platform. It can't compete with the throughput of phage or bacterial display, or sorry, phage or yeast display, but it can do a lot of other aspects of antibody engineering. And then to make more proper spike-ins, or to use this for spike-in standards, we can put a dual promoter in the heavy chain locus, so you have 2 mRNA transcripts of light and heavy chain, or we could just go into the light chain itself and insert, engineer whatever we want. So this would be how we would see possibly it falling into that aspect. I don't have no time, so I'm just showing one slide as a shameless promotion of a study I'm trying to get into review. So this is a paper where we wanted to, what we call the balance of nature, nurture, and noise in antibody repertoire development, meaning that we want to see what the contribution is of genetic background. So mice that are all of the same C57 Black 6 background, we immunize them with different antigens, and we isolate free B cells, naive B cells, and plasma cells from the same mice. And we want to see how the influence of antigen has shaped the repertoire on 4 different dimensions: germline gene usage, clonal diversity, clonal expansion, repertoire size. This actually ends up being a huge study. We end up generating about 400 million antibody sequencing reads across this. And anyway, so the point was to try to address this, and we have a lot of, and if I had time I'd talk to you more about it, so you can approach me later if you're interested to know the findings. And for that, I just want to thank my group. These are the various people. Tariq Khan really did all of the hard work on math and mouse spike-ins, along with the great grad student Simon. The human spike-ins are being done in collaboration with Novartis, and Mark and Christina worked on the hybridomas. Victor, Ulrike, and Enkaleda were really on the nature, nurture, noise. Happy to take any questions. One more shameless promotion. I'm helping to organize a conference next year, which I think a lot of people in this audience might be interested, and we want to. It's going to be in Switzerland in May, and a beautiful location near the south of Switzerland, and it's to look at systems biology of adaptive immunity. So be very excited if anybody's interested in joining that. Thank you.
So based on your results, would you say that that using the forward unique molecular identifiers kind of obsoletes the need for the spike-ins? Is it like good enough?
You mean just to provide, well, the spike-ins we just use as a validation platform that the correction actually works.
You're not proposing that like in a standard library prep protocol, you should always put some spike-ins in if you want to be like, get like the best results. Like, it seems like it's not even necessary based on the concordance you got between the multiplex and the...
Well, the multiplex...
Sorry, based on the concordance you got with the correction that you did with the forward UIDs.
Yeah, I think it's more for the fact that if you screwed up your library prep, the spike-ins allow you to show, to demonstrate that. So if all of a sudden this R-squared value that's 0.98 is 0.75 because of something that went wrong in our library prep, it would be very obvious from the spike-ins.
So with your CRISPR-Cas9 targeting, have you ever done this in a hypermutating cell line like 1881?
I'm not familiar with that cell line, but we haven't done it, so obviously.
Okay, so I mean it's a little bit like DD40, but just from so mouse derived. So could be interesting because you could basically induce mutations and then select them for instead of just having a steady display. But you've never tried.
We haven't tried that yet.
Okay.
Really, really cool stuff. Going back to the previous question, though, is it true, though, that you would still need a spike if you wanted to establish an absolute level of your template molecules?
Absolutely.
You get
so,
relatives
yes.
without spikes.
No pun intended. You cannot get an absolute quantification with our method. This is a normalized relative frequency. If you wanted to get an absolute, you would probably have to use the. We didn't actually try to do that, but I guess it's like mass spec using like labeled peptides or something to try to get absolute counts. We didn't actually do that, so that would probably be the only way to do it would be with the spike-ins.
Could you guess that if you had sufficient coverage that you just look, you'd get some quantum effect, the lowest number of stuff that you find, the lowest number of reads of a particular sequence that you get would have by default to be sort of your unit, and then everything could be multiple of that?
Yeah, I would probably, I think in the end I would always have to use when you're using PCR, it's very hard to feel comfortable about an absolute count. In the end, I think it's always safer to go with a normalized frequency.
I'll ask one question. When you were presenting the results about how your concordance, you presented the results, if I caught it, between using the UID, the RT identifier, and that forward, the PCR identifier. And you used both of those in order to get the quantification. Did you separate out what's the effect if you only had the UID versus?
Yes. So actually, that was one of the. If you used only the RID or the UID, if you want to say it, the single molecule tagging, it's about a 0.80 R squared. So that's this black bar right there. That's RID based only. So that's if you don't use the forward ID.
And is that with sort of an error correction step on the UMI?
We did test how it doesn't change that much with and without error correction at that stage because you're just counting RIDs. So I think there is a supplementary figure in there where we show how the different stages of error correction impact that. I'd have to look at that again off the top of I don't know off the top of my head, but yeah. So it is pretty good with the RID, just not perfect.
I think this is really, really great stuff, and in particular, this bias correction. This is the kind of thing that I think would benefit us all. So the question is, how straightforward would it be to adopt this in each of the individual laboratories that do this kind of work now?
Well, there's a huge challenge with using this method, and in that you have to oversample your molecules. So if you tried to do an approach like this on, let's say, a very naive B-cell population, and you just wanted to get 1 million reads, a lot of times this doesn't work because every single reverse identifier there needs to be represented at least 3 times. So if you don't do that, and many experiments, I think, for people who have done barcoding have struggled because of that alone is a killer. And so we have a study that where we couldn't use this on every single sample for naive B cells because if we had, it would have required us the 400 million sequences. We would have needed 4 billion. Okay, so that's not really tractable. So it's not a perfect method for every situation. It's very valuable in some cases, but there are other techniques that one can use. One can use computational error correction like Mixer provides. That's an excellent approach, or other types of consensus building things. So it's not meant to be the solution for everything.
All right, so we've got about a 20-minute break or so, and we'll return back here at 4 o'clock. All right, so I guess we'll get the afternoon final session started. So this is the minimal data standards discussion section, and we don't have an agenda for this hour, except that we wanted to start off by showing graphically a little bit about what we had in mind for the proposal, just in overview format. So I'll just walk you through this, and maybe this can serve as a basis for our discussion. So what we would like to propose is a couple things. So first, on the first day, we presented what our minimal data standard was. And if you remember, it contains 6 high-level principles about what kinds of information ought to be deposited when you publish one of these repertoire sequencing studies. And so those 6 elements included the metadata at multiple stages about the sample, about the process, and basically 2 data files in FASTA or FASTQ format. One was the raw data, essentially the data that comes off of the sequencing machine, and the other is what we call the process data. And that, just to be concrete about it, that is the data where you have done your UMI corrections, you've done your primer identifications, you've done your MID identifications, you've done all of that, and it's at the point where you would be ready to submit these data into a tool like HiVQuest or like IGBlast. It's at that stage. And this is the data that we are proposing that one would submit with a publication. And we are proposing that you would submit this to the Sequencing Read Archive, SRA, or SRA in combination with GenBank, as we heard this morning, you can do. So the idea is that the experimentalists, the data generators, would be generating these data, and at the point when you're going to publish the data, we would like to get journals to require that when you're going to publish these kinds of experiments, that you're going to be required to deposit those in SRA or SRA combination GenBank, and you would have to have some kind of identifier when you're going to publish. So that's what our proposed minimal data standard covers. That's what we've kind of focused on. In the discussions that have been going on, there's a sort of second level repository that that's been talked about. So notice this information does not include any information now on the VDJ germline assignments. It doesn't include any information on how the sequences are grouped into clones. It doesn't include any information on diversity or any of these sort of interesting metrics that we calculate and tell us about the biology and the immunology, which are, of course, very important for our papers and very important for the analysis and knowledge. So we view that as a second stage, the analysis, the VDJ assignment, cloning, diversity, et cetera. And we certainly think that there's a utility, and it's important to get file formats and standards for sharing this level data, and whether that's something like VDJML, the changeover file format that we've been working on, or some other thing based on thrift or so forth. I think that's open for discussion, and we should discuss what's going to operate here. And once you do that kind of analysis, those kinds of analysis can be part of, can drive the creation of these, what I'll call, for lack of a better word, derivative repositories that would make available this kind of information, so a researcher could query and say, hey, I'm interested, I have this CDR3 sequence, or I have this antibody sequence, I want to know what other data sets is this receptor found in, or a similar receptor. And those repositories would make those kind of queries available. And we heard a proposal earlier today that those repositories could be, they could have common interfaces through thrift, which would support this kind of either distributed analysis or sort of write one code, be able to access multiple of these derivative repositories. So again, just to get concrete, so our proposal would be then that when you're submitting to journal, this SRA combination GenBank submission that comprises these 6 elements is what we would suggest be required for journal submission of these kinds of data. And that we would certainly encourage that when these data are published, that you would submit these additional information about VDJ assignments, cloning, and so forth to one of these additional repositories that conform to maybe some additional set of standards, but that is something that would be optional, not required for publication. So that in sort of graphical format is where our starting point is. And we'll open that for discussion.
Sorry.
And can you say why? Why stop there? I know that, I mean, from a very general perspective, not just your, so why is there no value of trying to immediately also take that second step and agree on, and then I'm not saying, obviously, as we've all said, that there's many different ways how to do the analysis, but why not try to now also have a strict recommendation or a clear attempt to standardize the output of this analysis format, which again from the being at an institute where there's primarily immunologists, that's the data that they would be looking for, and being not, I mean, I see how the bioinformaticians like the first part, but I do think for the most immunologists, the last part is much more important. So not having any attempts to standardize that up front now, I think is.
So I'm not saying that we shouldn't attempt to standardize it. I mean, I think we should be working on standardizing this part of it as well. But two things that I guess we as a committee we're thinking about. One is this analysis at this point is in a lot of flux. I mean, we heard from Andrew and others this morning, there's a lot of variability and movement in what germline genes are part of repositories that would go into this VDJ assignment. There's just a lot of movement. And so it may be useful to let that be sort of a separate stage of processing. Because I think when we make those databases that are going to be useful for immunologists to query, we may want to actually take the data from the sequencing read archive and reprocess it so that we map all of it against the same germline repository, for example. Just like, this morning we heard the talk from John, in that case, the sort of base level data was all in Geo, and to make something useful for biologists to deal with, he took all the data, took a dump from Geo, and then reprocessed it and made that available. And we would envision similar kinds of things happening here.
Okay, maybe I didn't say it clearly enough, but I completely agree with that. There would be many different ways who want to redo these analysis, but just the endpoint. I'm not at all aiming to standardize this, but the endpoint, there's biological reality, right? There is ultimately a CDR3 region of these antibodies. Trying to say, how do we report this? It's perfectly fine. That doesn't mean that I see no downside of aiming for standardizing this endpoint right now as well, and allowing still clearly all these things. It's very important to do the first part, and then allowing many people to redo the analysis part and benefit from new germline sequences and all these things. But that is going to be a crucial step of every current analysis in every current manuscript, and I do want to be able to compare to what the authors were doing. So if we do not standardize the reporting of the author's analysis step, just the reporting, just the final endpoint, then I see it's an opportunity lost.
But why should we lose this opportunity if we don't do it now? This suggests that there is a time window, so if we don't grab it, it's gone. And I think, as Stephen said, so this is the step now. Next year, then we can work on basically how to harmonize later analysis. The problem is that to standardize the output of analysis, okay, where does the CDR3 region start? Okay, this becomes a very religious issue, and the important thing here is with these minimal standards, this is something that people have to comply to, and we as reviewers will make their lives miserable if they don't. Okay, so this is in terms of game theory really something where there's punishment and cost associated to them. Everything else should be more an invitation. So where you profit from using the same data formats and so on. So otherwise, I think basically every one of us would agree with you that yes, there should also be this later reporting should be standardized. It's just that doing this within the next 48 hours is probably something that won't happen in a good and coordinated fashion.
Yeah, I mean, I was just going to follow up with Bjorn's comment, maybe describe it in a different way. So it's going to be very hard to standardize the process, right? Because this is what I mentioned, is that this is very much in flux. new tools and so on. But it seems you should be able to define a controlled vocabulary of the type of things that are going to exist in that derivative repository, right? You know there's going to be B genes and D genes and J genes, and you know there's going to be this notion of clones. So I think that would be, now I don't say you can do it in whatever, by tomorrow, right? But this may be a first initial step, and because that can then guide, for example, the idea of these thrift interfaces and what the queries become with having that defined vocabulary.
Okay, I'll go then. I think that we have to be careful about not confusing standardization with requirement. So I think that it would be a very good idea to standardize how one reports VDJ assignment, and if there's a particular way that the community can agree upon, I think that's fine. In terms of what is required, I think that the sequence data are what we regard as the primary data. And the minimum requirements are the requirements for the metadata that makes it possible to use the primary data. And to me, that's really the important dividing line, that the data themselves are not useful unless you understand how they were derived, the conditions under which they were isolated from the patient and that sort of thing. And I think that's what the minimal standards group is trying to do here, that you can then go on and analyze it in a number of different ways. And in fact, just to answer Bjorn on one minor point, we actually don't do the VDJ calls for our analysis. And so I wouldn't want to be prohibited from publishing because we don't do that, for example.
I would also say that I think there is an opportunity now, and it is a good time to say that we're going to fix everything, fix the schema, I mean. So, for example, even though the process for generating annotations can be highly variable, there's no doubt that I'm sure we can all come to like a lot of agreement on what the result set would ultimately look like. The other thing is, for example, a situation with like the CDR3, like you're pointing out, like, well, no one can agree on what the CDR really is, so we shouldn't define it now. But you know, we're not going to agree 5 years from now either, right? The point is everyone is here because we're kind of willing to all agree on one religion, for at least part of it, and so we might as well take the opportunity to agree on a religion for some other hard stuff as well. And so that's why I would also be a proponent for trying to standardize the downstream stuff now as well. And the other thing, by the way, is saying we're not going to do this in the next 48 hours, no doubt. We're not going to do the first 6 things in the next 48 hours either, right? I mean, this is going to be a process that will take months or longer, almost certainly.
I think that's what we've done over the past year. So I do think that first part is done. I mean, we have a set of elements. We have a manuscript that we've been writing that we're hoping is going to get sign-on from many authors in the audience to do that first part. And again, I don't think we're saying that we shouldn't start to move towards the second part, but we have this now. We would like to get some consensus and move forward and make a recommendation on this first part, and maybe over the next year, what we can talk about is how to push that further out.
And I meant the implementation is not going to happen overnight. Right? This is going to take a while for it to get, filter out into all of the kind of the systems that we use. So.
But also the implementation. I mean, we started talking with the SRA today and yesterday, and we will continue it. And it seems that it's not that hard to implement an SRA to require the first 6 elements, because a lot of them is already there. I mean, you already have to specify the sample, the donor. You have to make the association from sequence to a sample. So with all the MIDs and so it's already there. And also the metadata can be implemented quite easily. And also the element 6 as a process data is possible to store in GeneBank or something, but there's also the link to the raw data. So if we agree on the first 6 elements, then we can do it actually quite fast because they're willing to open up and add data columns if we want, and that's done.
Yeah, I agree. That also just brings me to another point that I don't think that we should require SRA accession numbers. I would think that we should give out accession numbers.
But the situation right now is if you want to publish, you're required to submit to a public database like SRA. And I mean, this is the standard right now. I mean, you have to submit, even if you don't require it, you have to submit your data somewhere. If you publish, the repertoire said, then yeah.
Well, yeah, I mean, I have two reasons why I think maybe we shouldn't require it. I mean, so we should certainly encourage SRA, I think. And for example, if you have raw data, you should put it in SRA. The main example I'm thinking of is like adaptive, where, for example, they may come to this group and say, we love this idea, we think the standardization is good, but we're just not going to give the raw data. We're going to give you, we're happy to give you the annotated VDJ
I mean, that's fine. I mean, adaptive will give you, fastly sequence level data. I mean, it's just that the counts are going to be corrected with their PCR corrections. I think that's fine. I mean, I don't see any issue with depositing that data in SRA.
So sorry. Another thing we could certainly do in terms of adaptive is someone could, and I just thought of this now, somebody could sequence it, split a sample, send half of it to adaptive, and then use that as a standard to calibrate adaptive data with everyone else's data. Yeah. That's just an idea. I just thought of that.
So Nina Prack has actually done that.
Okay.
She can describe. Actually, I should mention that she apologizes. She's not feeling well, and that's why she's not here today.
Okay. So far ahead of me there, which is great. The question I had was with implementation and the timing. What's the timeline you see for implementation of these standards, and will some be implemented, faster than others? For example, will reviewers say immediately we need this done, and 2 years from now we'd like this done?
So I would say, as a community, if we agree, as reviewers of many of these papers, we can decide that we're going to request this when we do reviews. I think sort of the requirements is going to come further out, right? I mean, we are going to have to talk to journals and get journals on board to make sure that when you are doing these kinds of experiments, that they're going to require the authors to make these kinds of depositions. I mean, that's going to be a process.
So maybe, kind of an idea, maybe with the implementation, with the suggestions, we could put a suggested timeline, and certainly that might be up for comments. But that might help, because people have studies that are happening now that aren't going to get published for 12 months, and they may not meet the standards now. And so kind of like a phased in, a gradual implementation of the different standards, depending on how difficult they are, so that people who are doing studies now don't kind of get lost in the middle ground.
But maybe it's hard to put a fixed timeline on it. I mean, if you produce the data 2 years ago or something, I mean, sometimes it takes time to publish. And so, I don't know. I mean, just depend on the reviewer or the journal to accept, okay, I see that you can't get the data anymore because you have to produce the data before you know that you have to collect certain information, so that therefore it's okay.
Yeah. Could also tie the timeline to the sample draw date or the analysis date rather than the publication date. And that, just ideas.
Another fact is also that the things that we are put together in this are not things that usually don't have. So we are not starting something completely new that we are requesting that would make people go crazy to find this information out. This is normally you have it anyway written in your lab book, or most of it should be.
Thanks, guys.
Yeah, but so the easy part was, I mean, we had the core group of the discovery contracts that had to agree most of all. So that was our standard setting. Then the rest was kind of optional. So I think this is a little more tricky, right? Because there isn't like a core group of funded discovery contracts that are the main drivers. I guess this is more of a community.
I was just commenting that the IEDB went through the process of engaging journals and societies and international meetings to offer this as a standard for the epitope. And eventually at least one journal bought into the recommendation to use it at least, if not requirement. I was just asking Bjorn if he would explain the engagement process for talking to journals and societies.
And I was trying to say it was somewhat different compared to here because we had like the core group of NIH-funded discovery contracts that were essentially first agreeing underneath themselves that this is what we wanted to do. And then this outreach effort was a very voluntary one, specifically because we were also not funded as the repository who takes everyone's data. We were not pushing for it, but we were engaged more by like Journal of Immunology. They came to us and said, can we please list you as the repository? So it's a little different setup, so I don't think it compares. We didn't push actively for it. Actually, it happened organically from the other side. So I don't think our timelines are comparable.
So I don't know if this is so much a request for a change as it is clarification, but it seems like for the repository minimum standard and element 6 here, there's a gap between them. It's sort of, if you were to interpret them strictly, require researchers to have 3 different layers of analysis. When, depending upon the tool they use, you may not actually get out what's the minimum standard for element 6. You may not be able to separate the pre-processing from the VDJ assignment, dependent upon the tool you use. So I think as long as element 6 is a minimum standard, that if you were to provide data that was also adherent with the minimum for the repository, that would also suit element 6. Be kind of a middle ground. I don't know. Thoughts?
So you're talking about some cases where you might actually be using, say, the VDJ assignments, or at least the V assignments in some of your correction methods or things like that.
Well, let's say you use Mixer. It's going to do all your pre-processing and dump you out VDJ assignments. And you're not going to be able to pull out the steps in the middle before you did the VDJ assignment, or some new tool.
That's true, but you still could submit the FASTA formatted sequence file. I mean, so you may have additional information as well, which we wouldn't prevent you from submitting and annotating your sequences with. But that's what, in that case, we would suggest that you put that in as your element 6.
So yeah, so you could satisfy both minimum repository and element 6 with the same file?
Potentially, yeah.
So a separate thing. First of all, it's really useful that you draw it out because I finally understood where the disconnect is. And I think there's now, and I'm hoping I'm speaking for all of us, the disconnect with the derivative repositories and Thrift. We were definitely thinking that the stuff, definitely the relevant metadata, would be that part that is computably standardized across the repositories. I was always thinking this is one thing, right? That's why I'm arguing for it. To me, there was no separation there, but I thought this is what a repository analysis includes all these data elements, and the stuff that we are talking about in terms of having a computable formulation of the standard rather than you should kind of talk about the information, how you do kind of this processing, was the goal, and that we would have these kind of, in order to be able to ensure that the relevant metadata captured in one repository or the is really exchangeable, that you have an exact and computable definition of what should be captured in the fields, which is not what you currently have in that Excel document, where you have a recommendation of what you should provide information about, but not really a hard and enforceable and encoded standard. So there's definitely a disconnect there in my mind. I don't know if this is... No?
I mean, I think also one of the outstanding issues is whether you can put the metadata into SRA in kind of the structured form that we wanted. So if it's not possible at all, then for sure there has to also be kind of a repository at the front of this holding that metadata. But it sounds like maybe that's not actually the case. So the metadata all the way through element 6 can in fact just go straight into SRA. I think as Steve mentioned to me earlier, that doesn't preclude the possibility that the metadata is also still pulled out into the downstream repository as well. And so in some sense, this is kind of more of like a drawing of like the potential implementation of how this would look in reality.
The idea is that SRA captures the basic information, also the basic metadata, but it will not be able to cover every circumstance. So it says, I mean, I'm also part from import and try to capture everything, how the clinical trial is done and so on. This get massive. So so the idea was to capture the basic, the minimum at SRA, and this is the start point for another database or something, so that can be repopulated automatically or something, and then you can add other data, like you go to import or where you add a lot of other metadata about site-off results or something from the same person, same time point, or you use an IDB and add more epitopes or something. So this is the basic, which is the basic for other databases. This was the kind of idea, because I don't think that we can implement everything in one place right now. So then no one will use it. This is my fear. And SRA is what you have to do right now in some kind of, and they already have a lot of annotation possibilities. Not everything, but a lot.
I think I'd go back to what Tom said earlier. I mean, we draw a distinction between the technical aspect of actually doing a sequencing run and collecting the minimal data that anybody that does that run requires to understand it, versus further experimentation on that. And I think the setup is pretty clear to me anyway. But so I apologize, I missed yesterday, but did you guys discuss the details of what the relevant data is? And it seems like part of the thing here, the confusion is around exactly the details. Well, what do you mean by relevant metadata? What do you mean by the level of processing that's required? I think maybe if, again, and I apologize for not seeing that yet, it's already out there, but is that something we're going to talk about, or is it useful to talk about now?
We have a list on the AIRR homepage site, and you're free to comment, but we try to find the 6 core elements with specific terms, but not with a controlled vocabulary. But we define the fields, let's say. So this is the donor, this is the sample, and the diagnostics, or what is the run, which sequence I have to use, and so on. So there's a list online.
But we presented that sort of line by line yesterday. We went through that.
Yeah, this really helped also, and now I kind of understand element 6 better. And I just want to make sure, I mean, I think we've all along kind of said, yeah, we need the raw data. SRA is a good place for it to be. We need these metadata that would allow you to understand how you did your quality control and you did your merge of your paired reads and everything. But just so, but then would element 6 couldn't also go in SRA, right? You think element 6 could go in SRA?
SRA, a combination of SRA and
Oh, okay.
Yeah.
Okay.
So we just talked. So it's possible to upload it to GenBank with a direct link. So the reads or the sequences are linked from the process data to the raw reads.
I missed that when Ben brought up GenBank. I mean, there was no way.
Shortly, he has another talk, but he will be back on Thursday.
Oh, okay.
Try to pin it down a little bit more, and we'll follow up on it. But in principle, it's possible.
In principle, it's possible to put these mega thingies into GenBank, or 6 goes into SRA also?
No, the raw reads in SRA,
yeah,
and the process in GenBank.
Even though they might be 290 million per patient and blah, blah, blah. Oh, okay, sorry. Okay, well, that's good. Okay, that's wonderful. Then just to make sure, am I just being way too simplistic? I mean, if this group came up with a recommendation, you know, that VDJML, at least for human data, and that ontology worked. Is that just like, am I just being way too, there would be a strong, there'd be a lot of people that wouldn't like that. Is that true?
Like what?
You know, if we asked, would there be could we come up with consensus that, in fact, the ontology built into VDJML would actually work, and could, you know, that it'd be a lot easier to get to the derivative repositories then, because they'd use the ontology based in VDJML. I mean, yeah, like somebody said, in 5 years we're not going to agree on what a CDRH3 is, right? Yeah, we can't agree on now. We're not going to agree on 5 years. But we agree that it's workable.
I think that most people have never used VGML here. This is one thing, and yes, maybe, but I would just say maybe as a recommendation for now, and not as a requirement, and we try to define the requirements. But for now, maybe in 1 year okay, if it's established, if it's working, we have also some tools for it, then yes, then we can say it's a requirement for the 0.7, 8, and so on.
I'm going to give you a very quick comment based on my experience with sitting through many of these meetings with different communities who have struggled with all of these issues. So just, I like your model, and I'll tell you why. I'll give you a bit more support for it. So the first thing is, in terms of putting it into SRA and GenBank as your primary submission thing, you're going to keep the trust and credibility, because there's might and majesty and sustainability behind those resources. So the main issue that you have confronting most communities that are trying to set up commons for materials or reagents or data is issues of sustainability. So most of your derivative repositories, and we've had some ecological or evolutionary theory concepts about, you know, the strongest will survive. Not necessarily the funded ones will survive, and sometimes that's not necessarily the strongest. So you're always going to have issues with sustainability on your derivative repositories. That said, you need them because different jurisdictions have different submission rules, and you're going to end up, when you have a federated database, you're going to end up with needing to have some jurisdictional heterogeneity, both to access funds and also to comply with laws that might be specific to jurisdictional borders. So I think, you know, you've got a nice blended model, but at the end of the day, if you actually want people to be contributing their data, they are most likely to do it if they don't believe that the repository won't be there in another 6 months' time, at which point it's a bit of a waste of their time. So you have a nice blend that takes into account some of those jurisdictional and sustainability issues. The next thing is to look at the governance of what that interaction is going to look like.
Regarding analysis, I totally accept what Tom said about not wanting to restrict anything in terms of the downstream analysis. The one thing I wouldn't want to see as being optional has to do with reproducibility and having a strong sense that people have to be very specific about what they did, what they used, and so on. And how does that fit into what we're proposing here?
Well, I think this is exactly the point of this group. It's to enforce people to put the data, as Stephen already said yesterday, it's like for microarray data, so we have to make those data available. And since we still don't have any real idea of which method for library preparation, sequencing, counting, whatever correction we use is the good one, this way would be the way to get back this data and try to model and probably one day focus on standards. So, yeah.
I guess I would also add to that when we do these kinds of analysis and these kinds of studies, we have a responsibility as researchers to put the relevant data somewhere. So if I'm doing cloning, I want to specify the clones and the groupings and all of these things. And for new analyses, you want to put that somewhere. It's a question of whether that's part of what we're going to say sort of require for journal submission, or how much sort of discretion we leave to the researcher. And at least, again, sort of what we're saying now is that this is a reasonable, we see this as a reasonable line at this point in time for what we want to require, and we should continue to talk and see what other elements we want to start to bring in. And I would say the same thing with what Bjorn brings up about controlled vocabularies. I mean, I do think that we should, I agree that the data elements in the fields that we've been proposing are not yet standardized at the level of controlled vocabularies and links to ontologies, and we would very much want to get there. And I think that's going to, again, going to be a process that we need to go through to get to that point.
One more thing to reproducibility. It would be nice if you can start by raw data and get sent to the process data out of the information perfectly with providing the script from the researcher. But it's not necessary, but we would like to have the cutoffs kind of. So what, just some numbers, what have you applied to come from point 4 to point 6 without be able to do it directly by myself right away. Kind of.
Maybe we should also standardize our own vocabulary, especially I think I pointed yesterday already that the definition of the working group on publication is not really publication, it's what is deposited with a publication. And there's a difference between requirements and guidelines, and those are quite clear. And I think what we have at the moment is some working group on standardization of repositories, and that's clearly standardization. We have requirements for what is needed to be submitted with a publication, and we have a work group on tools. And for me, there are two gaps that are missing here, and this is all the discussions that we're going here, and I think what we need is guidelines. That's what is missing. And this is totally different from requirements and totally different from standardization. And especially if tomorrow we discuss and we decide that we want to be an association or society or whatever, I think that publishing guidelines is one of the main things of a society to do. Besides those three important tasks that you've been doing, and I'm sorry I'm coming here late and trying to kind of correct things, but I think that what has been done until now is really great, and I see two gaps in two guidelines that might be needed. One is guideline for what is needed in a publication, and I'm really talking about publication and the most right part of it, and even more right than the right. Really, what has to be in a publication in order for this publication to be reasonable? I'm not even talking about good, because that's, of course, needed. But all of us as reviewers, of course, we also need to require that all this information is deposited as part of the submission. But as a reviewers, we also require that some things are shown in the publication, and I'm talking in the publication itself. And I think as a society, it might be our job to publish guidelines, not requirements, guidelines, what would make a good publication in the field of AIRR. And the other guidelines that are missing for me in all these discussions that we discussed until now are between tools and publication. Because the tools work group is talking about how to make the tools shared, how to make protocols shared and everything. But there's no guidelines on which protocols are to be used in order to be in the state of the art. And again, of course, this is totally an open end from the top. I mean, the last talk is amazing, but how many people are going to be able to use spiking and things? I mean, we don't want that to be as a part of the guidelines. But on the other hand, I think many people are going to accept that using only a single barcode is certainly not the state of the art anymore for multiplexing. So there are, between those two
levels, there are some guidelines I think that we can accept. And again, submitting a review, and just a review would be enough, a review of T-cell receptor repertoire protocol, a review of B-cell receptor protocol, etc., would be enough. But a review that is backed up by a society has even more power. So those two gaps are missing, and those are two guidelines, I think, and not requirements and not standardization, just two guidelines. And I think this also covers a lot of the discussion that was going on here in the last 10 minutes.
I mean, when we sat together with the groups of the repositories, Yuri actually made a very nice move. He said, let's draw a box where we like should stop and what should be included. And I think part of this figure that we put up here is also to like show the border of where we want to go and where we want to draw the box. And the box for us at the moment is definitely around element 6 as the far right post, and element 1, which is not even on here anymore, as the far left post. Everything that comes after that will be subject to further discussion and maybe even different work groups, I would say.
Let me try to make the case for specifying the controlled vocabularies. So I don't know how many people remember Miami and all these things, right? That's what you're doing. You're defining these elements. So who's still using Miami? So it was a useful thought exercise to say what kinds of things should be included. And having a Miami compliant submission was never really well defined. And so yeah, you have some data elements there, and the typical user will fill in other or not available. And that passes the validation because you filled in letters in a box. And so coming from, again, from the repository side, you read the paper and they say, oh, it's epitope with peptide 3. Great. So what's the sequence of peptide 3? The postdoc is gone, nobody remembers anymore. Or it's, it's peptide at position 100 to 104 of influenza HA. Ha ha ha. So you have to force people, put the amino acid sequence down. They say it's obvious, it's the same peptide protein sequence we've always used. If you don't have a computable standard, you don't have a standard. It's kind of it's the text mining idea that people put something in and later I'll use my text mining tool to figure out what did they mean. Did they use the vaccination in the field where you describe the donor, and then this might be a vaccine study and I'm gonna pull those out, and then you're gonna have vaccinia virus coming back as a vaccine and things like that. Okay. So I realize that it's hard, and you cannot probably right now have a completely computable standard, but minimally I would beg you to have some level of validation, to at least get people used to, you will be turned down. Not available is not a valid choice for, say, the host organism. And at least so there needs to be some kind of enforcement here, and I would really want to see that. Then if you don't have that level of enforcement, then it should not be a valid entry for these repositories. And then
So what exactly? Sorry. What exactly are you arguing for and against? I mean,
the current Excel sheet that you have.
Yes.
Is not a specification that is computable in any form. It's a guideline where you can say, well, this is kind of elements I should talk about, but I cannot ask a computer, did you or did you not fill out these relevant data elements?
Yes,
you're going to look for an SRA accession number and an NCBI and GenBank accession number. That's the only thing you can get back.
Yes, it's content, and we don't right now specify a format. And which could be checked by regular expression, whatever.
That was what we were aiming for with this whole thrift thing. That's what I was trying to say. So the standardization that we were aiming for having, this is also what the compatibility between what is now called here derived repositories. We were thinking this is one stack, and that we were thinking you submit not directly here, but you would submit to the AIRR repositories, which would then pass on the data to SRA, pass on the data to GenBank, ensure that the metadata that's in here is compliant, and give you a beautiful...
But for these kind of things, you would need funding, right? I mean, somebody who does that.
No.
Not.
Okay. Minimum.
So I think it's a good, I think it's a good idea, and I guess maybe this is something we should discuss as a group tonight before we get together for the additional discussion tomorrow. But it is probably something that we can do for some, for at least some of the data elements and some of the key data elements, which maybe we can define as a group. Things like, like you mentioned, the organism or the cell subset that we're looking at, and things like that. So maybe we'll take a pass at that and see what we can do in the next 24 hours and try and adapt.
Yeah, to this, so SRA and so on, they have some parts standardized, so we can see what they have and we can adopt. And but it's also in principle possible, I don't think for now, but for the future, that we create our own surface, and then you can enter all the data there, and then they get automatically populated with SRA, so they will be stored there. But you have a checkpoint, so okay, this is the field you have to enter, and then you have a drop-down menu what you can enter. And if you fill that out correctly, then it comes to okay, and then it's AIRR approved, and then it's going to go upload, download to SRA. So, so for future, it's possible to have exactly this checkpoint. For now, but it's not completely against it, because if you have specified the fields, then we can add the terms later.
Well, I'm sure this is going to be less controversial than what has been discussed so far, but Ramit Mer, who's from Remote, has a specific suggestion for phasing in these sorts of recommendations. So she says publish all the recommendations and guidelines now, and give a year for community feedback, ask for feedback from researchers, reviewers, and editors, and then next time, I don't know if she means next year, discuss all the problems that were raised and modify accordingly.
I think if we hear that SRA is ready to go relatively quickly, we should try and move a bit faster than that, at least in getting the metadata set up. I mean, somebody asked, is there any urgency in doing this? Well, collecting the data with the study. If we don't collect it when the study is deposited, we'll never collect it for that study. I do think, by the way, that we need to do a bit more of a drill down to make sure that SRA really can meet our expectations, both in collecting and verifying the input data. And so hopefully they will be coming back and saying, we need a list of the options to put in this drop-down and all the rest of it, and we'll have to produce it at that point. But also I think we need to verify that we can query it in the sort of way that we want, or at least that we can get a dump of all the data out of SRA on a regular basis, just before we go ahead.
I totally agree, and I think if we if this is the decision that we're making, that this is a reasonable, conceptually at least, this is a reasonable path forward, that's what we'll start to concentrate on over the next several months.
And one thing what we are hoping for is to get approval that the community thinks that it's a good way to do, and then we can go to SRA and say, okay, the community thinks we should do this, can we do it now? And can we all add some part of process data, so element 6 as well, and they're good to go. But they also need some kind of, that the community stands behind it. It's not only one or two people, it's, community approval.
I don't know. I mean, I guess since we were thinking about having some kind of votes on these things tomorrow, I mean, I wonder about just getting kind of a straw poll idea of opinion. Say the scheme that we put up here, that we, as a community, we require with journal publication submission to SRA or DBOP or GenBank this level of data, so the sequencing files up to the point of where they would be reasonable to submit for a BDJ assignment. Let's say the standard that we proposed with some controlled vocabularies that we will define. So let's put that in there. Versus trying to take a different tack and include all the VDJ assignment and the cloning and all that level, a much more expansive standard, say, or something else unspecified. I don't know how many people sort of are comfortable as a community sort of recommending the workflow here. All right, that's pretty good. I think there's no question that we want. Oh, maybe there's a question, but I would think we would definitely want to start addressing the other parts as well. I mean, how many people think we ought to be thinking about as a community about the downstream kind of analysis as well and putting standards on that? Okay, okay.
I think this is very well illustrated also with the errors that we put in there. I mean, on the first part, everything like comes together because that's what we're all doing at the moment, whereas at the second part with analysis, that's where everything goes apart, and bringing that together would be a much stronger effort, right?
One potential caveat with the SRA is, as far as I understand, they don't put a lot of enforcement on the metadata fields. I know we've talked about this within the working group, and frankly, based on the conversations today, it seems like this is a really, really good option that is a lot less work for us as a community. But since this is all about minimal standards, and we're talking about having an SRA extension as sort of the requirement for publication, there seems to be a gap there. Because you can get an SRA extension without having followed the minimal standards. So that's my only little caveat. I think that, this workflow looks really good to me, and I think that it's very efficient compared to some of the other things that we've discussed, but I wonder about that gap there.
Maybe we can get them to put a field in which, could hopefully be automatically completed, but if necessary, we could do it by hand, just saying this data is AIRR compliant or non-compliant. By the way, just one note on the future. I think for the next step, we should focus on the schema and not get too hung up on file formats. And I just caution us against adopting a standard of a file format before it gets widely used in the community. It's very easy to make mistakes and get hooked on something that isn't actually that good. The winning file formats will out because people will start using them. What we need to think about is content.
So I think, somebody had mentioned earlier the possibility of issuing AIRR accession numbers. And that would sort of seem, instead of a field in the SRA, this is AIRR compliant, that might be a better way to handle it and allow for us to curate and to validate that things are following the way we want. But then we get back to questions of implementation timeline, because we're not ready to issue AIRR accession numbers, whereas you can get an SRA accession number tomorrow. So just something to think about. Like I said, I do think that this workflow looks like the right path forward to me, but there may be details there that still need to be worked out in terms of really making sure that the minimal standards are actually minimal, as opposed to just, we hope people do this.
Completely agree. One other benefit, it was pointed out that the SRA is something that's viewed as quite stable and is going to be there for the long term as a benefit. The other benefit I'll point out is we of course want all of our data to be open, but the fact is there are still data sets and studies that have human privacy protections on them and that need to be deposited in repositories that deal with that. So with this workflow as well, you have the possibility of data getting deposited into dbGaP, which does handle all of that oversight and infrastructure, which is really a non-trivial matter.
I mean, is a possibility to endorse for like the first year or so, you want to start immediately, put it in SRA, and that's the accession that you need. And then as a group, say a year from now, or however long it'll take, we will start providing accession numbers. I think that maybe that is maybe the best point of all with regard to the accession numbers, is that how do you actually know that this group has considered this to be a valid submission, unless the group says it's a valid submission.
But first, we have to be a group. So, I mean, right now, we are here and we say we are a community, but to speak for a community, we need some kind of formal association, right? But yeah, then we can try to implement this. But I wouldn't, with a timeline, I would be a bit, I don't know.
You're proposing this operating under the assumption that like AIRR may completely dissolve, and this would still be good enough.
No, I'm just saying that right now, I cannot go to SRA and say, okay, here you have to add the field IIA approved, and then they ask who is IIA, and say, yeah, we have had a meeting, and we supposed a meeting before and a meeting before, but who is member or who is there? I mean, it's nice that we have it, but if you want to implement it and talking with organizations, then you also need kind of formal agreement, right?
I would also suggest we can work with, try and work with SRA to make some of these requirements and restrict fields and validate fields to some of the recommendations that we make. Another possibility that Florian brought up is as a community we can develop validation codes that these data sets would have to run through, and that might help people comply and get these data sets more standardized.
I think that it is important that we talk about a more formal association, but I think that we can also, in the meantime, simply ratify or endorse these guidelines and say we the undersigned without saying that we are a particular organization. And I think that publishing that in the appropriate place would have a lot of influence. So I think, I agree. I mean, I think, and we are going to be talking about the association, but I wouldn't want to get tripped up for not having it at this point.
Right.
So as a proof of principle, you might be able to set up, someone could set up a simple web form that generated the XML needed for automatic batch submission of biosample and SRA data, that it had all the minimum fields you needed in there. So that would be one way to do it without having an official system in place.
Yes, I will mention there's the Cedar Center out of Stanford that's part of the Big Data to Knowledge initiative, and they are trying to develop a system where you can essentially design these kinds of data submission web forms and put controlled vocabularies and ontology linkages on the field. So one possibility is to use a system like that to implement an SRA type submission that conform to this standard. Definitely can talk about that. All right, so it's a little past 5 o'clock. So what next? Felix, you want to tell us what's going to happen next?
So we have a second session starting at 6. Tonight it's pipelines and integration tools. The second package in your package, I also wanted to point out at the last couple pages are a list of participants with emails and where they're from and everything. It would have been nice for me to say that before. It is in the Regency room again, and then we start back here at 8:30, I think, tomorrow morning. Yeah, back here at 8:30 tomorrow morning.
All right, and I'll make an invitation. Anybody who wants to discuss controlled vocabularies after the demos, dinner tonight.
You got some approval.
Yeah. Well, I mean, no, I mean, we want to come for dinner, so we need to. Okay. Okay, and let me ask you something. Yeah. I don't really know, but I would say you might make this meeting pretty
you.